Well, hello and welcome YouTube. Mr. Robinson back here with yet another brand new exciting video, all math-based of course, and as always, it is an honor and a privilege to be serving you here today, as it is every day here in my virtual classroom. Step on inside, and we are going to go to section 4.4 of the Big Ideas Math Integrated Math 2 textbook on solving quadratic equations by completing the square. Now, our previous section that we did was section 4.3, solving quadratic equations using square roots, but that was specific to having an x squared term with no x term, or x squared quantity, a quantity squared with x in it. And that second part actually is going to be pretty imperative to what we do here, because in completing the square, we can get to that stage. But listen, completing the square is a way that we can solve any quadratic equation that we ever want to, if they're real solutions, or non-real solutions when we start hitting sections later that talk about those. Or in section 4.5, when we also use what's called the quadratic formula, only derived by completing the square. And I hope the book kind of talks about that and brings that up. But solving by completing the square and quadratic formula, section 4.4 and 4.5 are the way you can solve any quadratic equation that's solvable. Period. Solving square roots is very particular to having just the x squared term with no x term. Let's introduce that x term and throw that in there into problems that are factorable and non-factorable. And that's the point. Solving by factoring can only get you so far. Solving by graphing is very hum. We can only do that for integers. It's a nice visual representation, but not really the way to go in full. This is it. This is it, 4.4 and 4.5. So let's see how the book talks about it. Let's see how I get to talk about it. We'll see if I have to pull out a calculator later. I think there's 70 some odd problems. I'm going to go ahead and get started here. And getting started by talking about the lecture portion. We are going to complete the square for expressions of the form x squared plus bx. Yes, a lot of problems, whether worksheets, websites, whatever, books, they like to begin with saying, hey, just complete the square. Just get the practice in. Solve quadratic equations then by completing the square. So after doing so, using the process, how do we then solve an equation? And I'll tell you what. I just talked about how 4.3 is a big stepping stone into this, because this is the this is the part that you do before you solve using square roots. Solving by completing the square gets to the part where you solve using square roots. So we get to that stage, and that's the part I don't have to teach again. If you go to that description section down below, check out section 4.3 in the Big Ideas Math 2 playlist that I have. You can check that out, and if so, you can make sense of what we do after we complete the square and factor. Find and use maximum and minimum values. Okay, now we've done that for vertex form of quadratic equations. I suppose by completing the square, you can get into vertex form, which I really wish we taught this chapter before, doing vertex form stuff, and solve real-life problems by completing the square, of course. So I'm going to marry myself to completing the square for this stuff as often as I can or need to. Perfect square trinomials is a big, deep part of this. In completing the square, you create a perfect square trinomial. Coefficient, we're going to have to talk a lot about coefficients, the a and the b and things like that. Maximum values, vertex form of a quadratic function. Yes, we're going to get in vertex form by completing the square. Okay, let's see. Yes, it looks like they're getting a good deep talk into what we're going to do, even with these tiles. I'll try and explain that. To complete the square for an expression of the form x squared plus bx, we're going to follow the steps. Find 1/2 of b, the coefficient of x. You're going to hear me often say divided by 2. Take this number and divide it by 2. And then we are going to square that result from step 1. Whatever you divided by 2, you will square. You add that result to here. So we're going to come up with some C value, y'all. We're going to come up with something that forms what's here called a perfect square trinomial. I mean, I'm not going to say we haven't heard of perfect square trinomial. That existed in all of chapter 2, section 2.3 and 2.7. Perfect square trinomial is something that factors into something squared. So this C will be very specific. It will be half of b squared. The square of half of b. And this is what it factors to, x plus b quantity squared. Now here's why. Algebraically, here's why. When we ask ourselves in terms of something factored, remember, b is not a variable, guys. B is like a number. Treat b like 4 or like 10 or like 2,000. We try and find what two numbers multiply to become this thing. And that's, I know that's weird to look at, but what two numbers multiply to become this and add to become this. Well, when you take b over 2, because b over 2 is that number, right? B over 2 times b over 2 is b over 2 squared. B over 2 plus b over 2 is b. Half of b plus half of b equals all of b. So the same number twice, right? And that's what this thing factors down to. Something twice in and itself becomes x plus that same thing squared. This is an x squared plus 2ab, or a squared plus 2ab plus b squared, perfect square trinomial that factors down into some a plus b squared, just like that. So we've seen a lot of that before. That's the algebraic reason. here's a nice justifying step in a visual, and I don't get enough time to talk about this to students because we don't do algebra tiles. But here's a nice visual of that. I have a rectangle of x squared plus bx in area, and I can factor that into x times x plus b. But let's cut b in half. Remember, b is a number. Let's cut b in half as far as that length and stick it over here. Here's half of b, here's half of b. We are going to literally complete the square. We are going to add in the result that gives you a square out from this. If these are the same length, x plus b over 2 and x plus b over 2, what's left to do is take this b over 2 times b over 2, and you get b over 2 quantity squared here. We have completed the square. We fill in that void. We fill in that void. Now, you might be wondering why we're doing this, because I'll give you these answers. This is 9, and this is, oh man, you got to give me that. This is 81 over 4. You got to take half of 9. And so, okay, we're going to do some odd numbers here, basically. Oh, they gave it to us right here. And sorry, this should have been a plus. I don't know why I put a minus. They gave it plus 9, and here plus 81 over 4. I forgot what I was going to say. Oh, we're going to deal with some odd numbers. So dividing something by 2 means we're going to deal with some fractions. Okay, we're going to be dealing with some fractions. What did I want to say beyond this? Oh, here's the whole idea about completing the square, guys. You might be wondering why we're doing it. Remember how we solved using square roots? That it was possible to do when we had something in a squared quantity to take the square root of both sides? That's what we're doing. We're finding a method to solving equations by using square roots. And what we do is we take this thing and we factor it down to it's a perfect square trinomial. That's the point. It's not just any factorable thing like x times x plus b. This is very specifically something squared. And in an equation, when we create it into something squared, we can solve them by taking the square root. And I'm sure they're going to start talking about that. But I really wanted to lead it in so you know what we're doing with it. Let's move forward. X squared minus 6x equals negative 15. Let's solve by completing the square. So here's what we're going to do. We're going to find the number that gives us a perfect square trinomial on this side. Now this time we're not just completing the square, we are working with an equation. What I mean by that is when we take a number and we add over here, we have to do the same thing to the other side of the equation, just like we do for anything. Subtract 2 from both sides, divide both sides by 6. We have to do the same thing on both sides of the equation. So when we complete the square, we're literally changing the result, right? What did we do before with this? Excuse me, with this rectangle? I just had a massive steak. With this rectangle thing, what do? We filled in more information. We just added value to it. So we made it a different value. This isn't an expression anymore. So now we're taking it, we're actually adding something. Now what are we taking? Half of negative 16 is negative 8, and squaring negative 8 gives us 64. And that's what we're doing. We're squaring that number and get 64, which means we're adding 64 over here. We add 64 to both sides. And one more time, why are we actually doing this? Because we made a perfect square trinomial that factors into x minus 8 quantity squared. It's this number, half of b, that goes in the factorization, which is an easy way to remember it, especially when we have fraction values that we have to do this with. Negative 15 plus 64 is 49, and now you can take the square root of both sides. And the textbook's doing this thing again. Square root of 49 is 7, but you get a plus or minus 7. This is the solving using square roots tactic from 4-3. Take the square root of both sides, you get plus or minus 7, so we get x equals, when you add 8 to both sides, like we did adding 64 to both sides. When we add 8 to both sides, we get 8 plus or minus 7. 8 plus 7 is 15, 8 minus 7 is 1. You could double check that by substituting them. That also means that this would have been factorable if I added 15 to both sides. X squared minus 16x plus 15 equals 0, and this factors into x minus 15 times x minus 1, which means x equals 15 and x equals 1, the same two answers they got before. You might be sitting there wondering, well, Mr. Robinson, that looks a lot faster. Why don't you just do that? Well, not every problem is going to be factorable. You can't solve by factoring if it's not factorable. You can solve by completing the square if it's not factorable. That's why we're just showing there's a connection with this kind of problem, and you can do it for literally any quadratic equation. So that's why. Excuse me. Second example right here. We're going to solve 2x squared plus 20x minus 8 equals 0. First step I would do, and they're doing the same thing, is you want to move this 8 over to the other. Actually, there's something else I would do before it, but you want to move this 8 over to the other side of the equation by adding 8 to both sides. Keep in mind, in completing the square, we are going to find the constant that forms a perfect square trinomial with our x squared plus bx. We need to figure that out. And by the way, for this problem, this is going to be important. They're actually talking about it right now. This needs to be a 1. This needs to be a positive 1. Remember, completing the square. It's the 1 square here. You can't take, right now, I'm not going to take 20 divided by 2 and square it. I think that's what they're saying. Common error. Before you complete the square, be sure the coefficient of the x squared term is 1. I can't take 20 divided by 2 and square it. If I did the tile basis thing, this isn't going to make a square out from it because this is a 2. We need to make that not a 2, and we are going to force the 2 out at all costs. The very fact that everything can divide by 2 makes this very much easier for us. Divide everything by, and listen, I would do this for any quadratic equation that I have. GCF, pull that thing out, quadratic formula, when we do that in 4 or 5, I'm dividing everything by 2. This isn't unique to completing the square, but in completing the square, this must be a 1 if you're going to make that happen. There are versions that other teachers are going to bring about. If I made it a 4, if I made it a 9 or a 16, all can be right, but this isn't a 4, 9, or 16, so I'm also not going to do that, and I hope the book doesn't either, because I don't do it, so I'm not going to do it. Anyway, now that it's a 1x squared, we complete the square. 10 divided by 2 is 5. I'm just writing what that number is. And then we square it to get 25. I know they're writing 5 squared. So you add 25 to both sides. This factors down as a perfect square trinomial to x plus 5 quantity squared. 4 plus 25 is 29. You take the square root of both sides and you subtract 5 over. You get negative 5 plus or minus root 29. Now, this is a perfectly valid set of 2 answers to me. They are approximating them for us. Negative 5 plus root 29. Negative 5 minus root 29, and of course those values are important. They will represent x-intercepts. But as far as what we're doing here, this is the exact answer. So unless they ask me to round, I'm not going to. I can see in these instructions here they are asking you to, so we'll probably have to. Finding and using maximum and minimum values. One way to find the max or min is to write your function in vertex form. Remember, the vertex represents the min or the max depending on where it goes. If it's an upward facing graph, you have a minimum. If it's I'm trying to find an upside down. If you have an upside down facing graph, you have a maximum. So how do I get something in vertex form, especially when it's in standard form? You complete the square. You do completing the square. Remember what completing the square allows you to create: a factorable perfect square trinomial like this. Now this is going to be slightly different from the previous problems because you don't have something set equal to 0 or something of that nature, or you put things on the other side. We have a y on the other side. In this equation in standard form, y equals x squared plus 4x minus 1, this is the standard form equivalent. Now there is a way that we've written vertex form in the past with this by using negative b over 2a. Let me show you that. As in, we would say the vertex x value was negative b over 2a, which was negative 4 over 2, which is negative 2. That's our h. Our k value is by substituting negative 2 in there. Negative 2 quantity squared plus 4 times negative 2 minus 1, which is 4 minus 8 minus 1, which is negative 5. So this is your h, this is your k, and your a value is 1. Your equation is going to be y equals x plus 2 quantity squared minus 5. That's the answer they also have down here. We're going to do it by completing the square, so you're going to have 2 different options for it. I personally prefer completing the square as often as I can get. I don't like using negative b over 2a. It takes too long. For you, the completing the square might take some time. Now, they do something that I don't do. I'm going to mention this right now. I keep my y isolated. They're going to move something to the other side, just like we did for the other equations when it equaled 0, but notice they do bring it back. They do 1 plus 4 is 5. They subtract the 5 back over. I keep it on this side. I hope you're okay with that, so I'm just going to tell you what they do, then I'll give you my version. They add 1 to this side because the 1, now listen, when I say keep it on the side, I would move it off to the side like that because I still need a number right here to complete the square, right? So they move the 1 over saying, nuh-uh, 1's not my value, I need to find something else. So how do we complete the square? We have a 1x squared, we take 4 divided by 2 is 2, 2 squared is 4, so we add 4 to this side, add 4 to that side. We add 4 to both sides of the equation. We have now made something factorable. This is a perfect square trinomial that factors to x plus 2 quantity squared, and 1 plus 4 is 5. Now we subtract 5 back over, which I'm not going to have happen, but we have y equals the x plus 2 quantity squared minus 5. So this factors into that. We now have vertex form. The vertex is now at negative 2, negative 5. Now what's interesting in what I said on the previous way that we did the problem is writing this in vertex form when I use negative b over 2a is of no real use for me. My goal of vertex form is to get the vertex. So if I got the vertex, writing vertex form is an extra unneeded step. But here, when I complete the square to get into vertex form, it gets me the vertex. So it depends on, do you just want the vertex, use negative b over 2a stuff? It's reasonable. There are times I may use it. Or can I complete the square, get it into vertex form, and work that out? It's up to you. Now, what would I do personally? Here's how I write it, just so you're aware when I do it for the problems. I kind of just kick the minus 1 to the side. and I'm going to add my number that completes the square, which is 4. Now here's the thing, I also said I don't touch the side with y. Remember how we add something to both sides of the equation? Well, if I add on this side of the equation, I can also subtract on this side of the equation to counter what I just did. 4 minus 4 is 0, right? Which it's not, the goal is not to cancel this out, but 4 minus 4 is 0. So I'm back to where I was. I've kept balance in my equation by adding and subtracting on the same side. Now, this is the one that factors down into x plus 2 quantity squared, and negative 1 minus 4 is negative 5. So I never move anything over in the process. I just move it to the side, and I add and subtract on the same side of the equation. I hope you're okay with that. Okay, here's another example. Now this one's going to be good. They do the same thing I do. This one's going to be different because of this negative here. Very crucial in understanding that negative 1 is not the same thing as 1. Unless it's a 1x squared, you are not properly completing the square. I need to tell you that for sure. Now they move the 7 over. Hope you're okay with that. I'm not going to when I do my own problems. But notice what they do next. They factor negative 1 out of the quadratic and linear terms. So the inside of here, they made a 1x squared. There's a positive 1x squared inside the quantity. Inside the quantity is where we're going to complete the square. Excuse me. Inside the quantity is where they're going to complete the square. Notice how this plus 2x is now minus 2x? Well, from here, we are now going to be doing what? We're going to divide negative 2 by 2, which is negative 1, and square it to get 1. So we add 1 to this side. Now, why don't they add 1 to this side? Why do they subtract 1? Because this isn't really just a plus 1. Remember what would happen if, which we're not going to, if we distributed this negative back into here, this would say negative x squared plus 2x minus 1. So technically, even though plus 1 is inside the quantity, a negative distributed into there means we're technically subtracting 1 on this side, which means we're subtracting 1 on this side. And yes, there's a stark difference between having this to begin with. If I took 2 divided by 2, is 1 squared is positive 1, this would have been a plus 1, and that is an illegitimate perfect square trinomial. This, however, is a legitimate perfect square trinomial. I will not distribute the negative, it'll stay factored out because this is the thing that factors into this squared binomial, from a perfect square trinomial to this. And negative 7 minus 1 was negative 8. They add the 8 over. This negative stays outside. This is vertex form. The stretch factor, A, is negative 1. Truly, that's the value. We need this x minus h squared, right? 1x minus h squared. So that same thing exists here. This is vertex form. The vertex is 1, 8. A couple more down there. We're going to do our own examples, of course. Interpreting forms of quadratic functions. Let's see what they're going to talk about here. Which of the functions could be represented by the graph? I know this can't because no positive stretch factor. 5, 9 looks possible. This is not possible because that's negative 4, 8. And this would have vertex of 2, 8. That's possible. I like g of x and p of x. I don't know what's actually correct, but let's see what they say. G or p. All right, I'm going to move on. It's the same thing as I said before. This vertex would have been negative 4, 8, which would have been over here. This would have had positive stretch factor, which would have gone upward. So not possible for those. These are good at 5, 9 vertex, and at 2, 8, x intercepts being negative means it could have gone downward. I don't know what this has to do with completing the square, honestly, but there it is. Real life application. I've done a lot of quadratic word problems in the past. This is no different. The difference is we can solve by completing the square as well, which means we don't need to just find integer solutions or rational solutions. We can also find irrationals. This one looks very rational, however. And we can practice getting into vertex form by completing the square as well, it looks like. The function y equals negative 16x squared plus 96x represents the height in feet of a model rocket x seconds after it's launched. We're going to find the max height and find and interpret the axis of symmetry. Now, the max height, well, if we find the vertex, this will be the k value, max height, and then the axis of symmetry is going to be at x equals h. So we want to find the vertex. So we want to solve by completing the square. Notice the very first step that they do, factoring out negative 16. We need a 1x squared here. It has to be. And that consequently turns this into a negative 6. Negative 6 divided by 2 is negative 3. Negative 3 squared is 9. We add 9 to this side. Why did they subtract 144 from this side? Because that's negative 16 times 9. Remember, this is not truly just a plus 9. It's whatever this number is multiplied by that. So we add negative 16 times 9. We subtract 144. Now, I'm going to do it on the same side of the equation. They do it on the other side. They bring it back over. X squared minus 6x plus 9 factors to x minus 3 quantity squared. Here's your vertex form. Your vertex is at 3, 144. X equals 3 is the amount of seconds it takes to reach the max height. 144 feet. Y is 144 is the maximum height. 144 feet. So to interpret it, again, their interpretation is on the left side the height's increasing, on the right side the height's decreasing. Yeah, that's fine. But it reaches the max height at x equals 3. More modeling with mathematics. We're still going through the lecture, 20 minutes in. Here we go. You decide to use chalkboard paint. This might be a long video. Chalkboard paint to create a chalkboard on a door. Okay. You want the chalkboard to cover 6 square feet and have it, to have a uniform border as shown. Find the width of the border to the nearest inch. Okay, the width of the border is x feet. This is a 3 by 7 foot door. It needs to cover 6 squared feet. So we create a scenario where, remember, it's x on both sides of this thing. X over here, x over there, and etc. So the width of the chalkboard is 3 minus these two x's. 3 feet minus this x and this x. And the height is 7 minus these two x's here. So that area, when you multiply those, will equal 6 square feet. So here's your model. When you take that height of 7 minus 2x, or they call it the length, and the width 3 minus 2x, it's going to equal 6 when you multiply them. When you, FOIL this thing out, you get this equation not written in standard form. They do a couple things. They write it in standard form with 4x squared first, negative 20 second, and they subtract 21 over to get negative 15. I know I'm going fast. This is the lecture part. It's already pre-written. They divide everything by 4. Now, I generally factor the 4 out. And I do the multiplication thing that you saw in the previous problem. They straight up divide by 4. There's actually no problem with that. I just don't do that. And I get a common denominator. Same stuff. Negative 5 divided by 2 is negative 5 halves. And negative 5 halves squared is positive 25 fourths. So we add it to both sides. Their version's probably even better because they automatically have a common denominator. Mine is just by nature of habit. You can do what you need to. Divide by 4 or factor the 4 out. But you do need it out of the way to complete the square. This becomes x minus 5 over 2 quantity squared, right? It's half of b is the thing that goes inside here, b over 2. And negative 15 fourths plus 25 fourths is 5 halves. We take the square root of both sides. So we take the square root of both sides. We're going to get a plus or minus root 5 over 2. And then we add 5 halves over. X is 5 over 2 plus or minus root 5 over 2. Looks like they're not going for the exact answer where you simplify a radical. That's fine. It's a word problem. And we look at the two possible solutions. There's 5 halves plus root 5 halves, which is 4.08. 5 halves minus 5 halves, which is 0.92. Interestingly enough, generally the bigger number is the one of the answer that we need to get. Not in this case here, because, you know, it's not about, this answer is not negative. 4.08 is too big. You can't have widths of a 7-foot tall door, and you can't have these edge parts be 4 feet big. There's too much crossover there. It's way too big. Same thing with the 3-foot side, obviously, but even the 7 feet, it's just too big. 0.92 seems to be the value that represents that width. Now, they wanted what for this answer? They wanted to find the width of the border to the nearest inch. Wait, this part? I don't even know what they're... Oh, this is the width of the border. Yeah, they just want the width of the border. Now, what do they do here? Width of the border is about 0.92 feet. Oh, they convert to inches. I see. They need it to the nearest inch. So this is feet, convert to inches, multiply by 12. 12 feet in an inch, 11.04 inches. Fantastic. All right, a lot of material there. We're going to do some of our own. There was completing the square there, actually. Let's dive into it, guys. One of the longer lectures there. Complete the sentence. The process of adding a constant c to the expression x squared plus bx so that x squared plus bx plus c is a perfect square trinomial is called completing the square. We want to find that constant that creates a perfect square trinomial so we can factor it down. That is the completing the square method. And I know people are opposed to it, but it's the way of solving any kind of equation. Explain how to complete the square for an expression of the form x squared plus bx. I'll say the way that I do it. It's what they do. I just say it differently. Divide b by 2, the linear coefficient, by 2, and square the result. Add that as the constant to the expression. So that c is b divided by 2 quantity squared. That's what makes a perfect square trinomial. Is it more convenient to complete the square for x squared plus bx when b is odd or when b is even? Explain. Significantly more when b is even. When b is even. We are going to divide by 2. And even numbers are divisible by 2. Don't worry, I'll shrink it. When you divide an odd number by 2, you get a fraction. And it's the one thing that we always go, oh man. Notice it does say x squared plus bx, by the way. You do need to first factor out whatever's in front to reveal what your true b value is. Anyway. Describe how you can use the process of completing the square to find the maximum or minimum value of a quadratic function. Completing the square gets your thing in vertex form. Completing the square can get a standard form quadratic equation into vertex form. And the vertex represents the max or min of a parabola. So once you have vertex form, you're going to then identify what that vertex is, makes it your max or min. I want to make sure that's visible for you guys. Excuse me, got some sniffles. I'm going to pause and we're going to go straight into the rest of this here. I just did one big sniffle and we'll see if that took care of it. Okay guys, so we are going to jump into the rest of these problems here. I hope you're ready. I hope you're ready for this stuff because I don't know if I am. It's going to be a quite a daunting task. I'm just getting everything set up while I'm just still behind the curtains. All right, let's go ahead and get started. In exercises 5 through 10, we're going to find the value of c that completes the square. So we're not solving anything here, and if you followed along with the lecture, this is just finding that value. Excuse me. I'm not even going to put the plus c. I'm going to put plus blank here so we find that value of c. I'm not going to write c equals. I want to see this for what it is. We take -8 and we divide it by 2 to get -4. We square that -4 and out comes 16. Positive 16. This will always be added inside the thing that completes the square. That is the answer. Number 6. X squared minus 2x plus c. And honestly, I think after these, well, not necessarily, but after some bit of them, all depending, obviously, you know how I end up speeding up times when I feel I can. That'll happen at some point where I'm not going to write this part. There's only one other reason I'm going to be writing this part after this, which is to show you how this thing factors. But at some point, I'll stop. Okay. Anyway, so -1 quantity squared is 1. That's what completes the square. And by the way, you do these enough. You look at, listen, we've done perfect square trinomials a lot. I don't know how familiar you are with recognizing a perfect square trinomial when you see it or knowing which number exists for it. But in section 2.3 and 2.7, that's all we lived on. Obviously, difference of two squares as well. But they become so familiar that I just know what the number is because I've seen it so often. I'm not even dividing by 2 and squaring to say x squared plus 4x plus 4. Okay, that's the number that goes in there, and that's the number that makes a perfect square trinomial. I've dealt with them in my teaching life. Maybe it's more so because I'm a teacher that I've seen it more often. I do it every year. But yeah, perfect square trinomials. On odd numbers, I'll compute it. On even numbers such as these, they don't faze me one bit. I know exactly what I'm going to get out of them. X squared plus 12x plus blank. We take 12 and divide it by 2 to get 6. And 6 squared is 36. Completes the square there. Sorry that I was talking through those problems. That's my way of coping, as it's going to be quite a long video. Number 9. We have x squared minus 15x plus blank. This is where writing this stuff is always probably going to make you a lot more comfortable. Dividing by 2. Try and avoid the decimals, guys. You've noticed fractions this whole time, -15 halves. And it's really easy to calculate because I don't have to do anything. I just said divided by 2 is this. And squaring this guy, we square the top, 225. We square the bottom, 4. And this won't reduce if that couldn't reduce. And this won't reduce unless you can actually divide it by 2. So you're all good there. That is the perfect square trinomial value. That's the completing the square value, I should say. Number 10, also an odd number, but a smaller one, which is nice. It actually reminds me of one of the example problems we had, if not being exactly the same. X squared plus 9x plus blank. I think the other was a minus 9x. But remember, your end result is something that you're going to be adding here. 9 halves squared. I'm just putting squared quantity. I'm squaring this, and we get 81 over 4. Okay, okay. that's numbers 5 through 10. Still a little bit of warm up here before we do the actual solving. We are going to complete the square and then factor. Remember what completing the square's goal is. It's to get it into a factorable perfect square. You know, it's a perfect square trinomial that we can then factor down into something. So I'm just going to do the same thing here. A little plus blank right there. Now, dividing it, I'm going to write this for just a couple problems more, or for odd problems, because at this point you understand what I'm doing, hopefully. Dividing negative 10 by 2 to get negative 5, and then squaring it here. Negative 5 squared is 25. Now, that's not the answer. They want us to then write the factored form of this. What two numbers multiply to negative 10, to 25 and add to negative 10? It's this number. It's this number twice. X minus 5 quantity squared. This guy is the guy that goes here. This is that half of b value. So that's the number that goes into there, which is nice to just know. It's just, you're not even asking yourself what two numbers do. It's that number. There's no thought. That's why that part's really easy to factor, because you've done the work to get there. Let me do that one more time with a problem like this. And after that, I'm probably not going to show that unless, like I said, we run into odd numbers. I'll say them out loud, but that's what we're going into. And by the way, that's the thing they're asking you to do. Complete the square and then write the factorization. So number 12, x squared minus 40x. Whoa, big numbers. Here we go. Divide negative 40 by 2 and you get negative 20. And then you square negative 20 and you get positive 400. So I need to know what two numbers multiply to 400 and add to negative 40. Oh, it's negative 20 and negative 20, my friend. It's x minus 20 quantity squared. It's that number that goes into there, right? So that's what we're doing with these. Hopefully it makes sense. Unless I have some odd numbers or I feel it's relevant to what I need, I'm probably not going to write that. So let's take a look at number 13. X squared plus 16x plus blank. Let's see if we can do this all together now, huh? 16 divided by 2 is 8. 8 squared is 64. You divide this number by 2 and square it. Divide it by 2 and square it. You might be, Mr. Robinson, why is it that specific thing? These are what makes perfect square trinomials. Something times itself, something plus itself. Half that number, add it. Anyway, that's the thing. But how does this factor? What number divided by 2 was this? It was 8. Positive 8. This is the number that goes there. It's obviously something you can come up with. 8 times 8, 8 plus 8. But it's half that number and the square root of that number. That's where we get that thing out. Number 14. X squared plus 22x plus a blank. X squared plus 22x plus, equals, oh, sorry. What's the number first? 22, half of 22 is 11. Squared is 121. And this will factor into x plus 11 quantity squared. Good. I hope there's probably running out of drill and kill here. I got two more, and even these ones are odd numbers, so maybe we get to revert back to what this said before. X squared plus 5x plus a blank. We divide 5 by 2 to get 5 halves. We square 5, oh goodness. Divide by 2 to get 5 halves, and then we square 5 halves to get 25 fourths. Okay, another important thing I want to mention. Students ask this and then they screw something up later. Mr. Robinson, what good is it for me to square this number if all that I'm trying to get out is this number out? You know, I take half of 5. All that I needed was this number to factor, Mr. Robinson. Why do I need this? Don't forget what we're going to do in actual equations. We're going to add this number to both sides of the equation. So this, sure, we add it here and it factors down that. I get that. I get where you work kind of a little, you want to work fast. You want to skip some little bits within steps. I get it. But this is going to add to both sides of the equation. So don't ignore what this is. Don't say that this only exists. Because what people start doing is they just turn this into x plus 5 halves squared without even thinking about the fact that this side is 17 and we had to add 25 fourths to the side, and you just never end up adding it. So don't skip steps. There's a necessity to why we do that. Maybe you can skip writing this action. I'd like for you to be able to get to that part. But before that, sorry if I'm sounding condescending or something. I promise I'm not trying to. You know, I hope that you can get there, though, because I'm going to start doing that. So it's something where, I forget what he said in Triple X. If you want to, you know, come with me, you got to go one speed, my speed. Or you can pause it or slow it down or find another video. But, you know, at some point, we got to understand process. Negative 3 over 2 gets squared to get positive 9/4. And yes, you add it in here. That's the thing that completes the square. You add to both sides of those equations, but this factor is now down to x minus 3/2 squared. Remember, it is that number. Without overthinking it, it's this number that goes into there. Okay, so those are the first several problems before we are now going to solve by completing the square on numbers 17 to 22. So they do say to round your solutions to the nearest hundredth if necessary. We would only do it for irrational solutions. Anything else we can calculate for ourselves, or they will just be exact integers. And it looks like they'll probably start with some exact integers here and there to get you warmed up. And then we hit the irrationals. So I'll have to get my calculator ready. We're going to solve x squared plus 14x equals 15. Now, they begin with us quite nicely. It is a 1x squared, there's an even linear coefficient, and 15 is already on the other side of the equation. Exactly what we want. Because we want to complete the square on this left side. 15 was likely not the number that would complete the square here, and we're going to find that number. And whatever we do to one side, we must do to the other. Just like any other equation where we do something to both sides of it, only this time we are finding that specific number. We're not really moving a term over. 14 divided by 2 is 7, and 7 squared is 49. I'm going straight into it here on out, if I'm able. Just keep in mind what that number was we were talking about, right? 7. Why did we do this? Because this can factor down to x plus 7 quantity squared, and 15 plus 49 is 64. Hey guys, at this juncture, we are now at a problem like section 4.3 would have done. I'm just going to star and put 4.3. If they asked you, if this was the beginning of the problem, they said solve this, we did this all in section 4.3. This is what 4.3 is chock full of. So what do we do from here? You take the square root of both sides. Your x squared term is isolated, or the quantity is. And now we have x plus 7 equals plus or minus. Square root of 64 is 8. And you subtract 7 from both sides. You get x equals negative 7 plus or minus, whoops, 8. Excuse me. There are two answers to that. Negative 7 plus 8, which is 1. I'm going to have to drink some water. Negative 7 minus 8, I hope this isn't some crappy ASMR sound, is negative 15. I'll hold my breath and do this. So those are the two different answers there, which also meant this was solvable by factoring. If I subtracted the 15 over from both sides, yada yada, we would get these two answers, and away we go. But we're solving by completing the square, and that is number 17. Number 18. Let's solve x squared minus 6x equals 16. Knowing my factorization, this is also a factorable problem, of which we are not going to be doing. We are going to do the exact same thing we got on this problem. We did on this problem before. Now, part of I don't know when the quiz part shows up, probably after section 4.5, I imagine. But I don't know if they're ever going to force methods on you, or if they start to teach you what method to choose. If it's factorable, solve by factoring. I mean, not in this section, but in general. If it's factorable, try and solve by factoring. If it's not, and I have a 1x squared and an even thing, completing the square is great. Negative 6 divided by 2 is negative 3. Negative 3 squared is 9. I'm going to add 9 to both sides. And this factors into x minus 3 quantity squared. Remember, once again, once I found out that negative 6 divided by 2 is negative 3, this automatically would pop into here. But I don't just write it because I must understand that 9 is being added to both sides. 16 plus 9 is 25. I can't just leave that as a 16. That would be an invalid and incorrect answer. Take the square root of both sides here, and because this is a perfect square, that does mean this was factorable. And rational solutions, ahoy. Plus or minus 5 appears. We add 3 to both sides, and we get 3 plus or minus 5. So those two answers, 3 plus 5 is 8, and 3 minus 5 is negative 2. I didn't have to drink water there. Number 19. Let's solve this. This is non-factorable, so this is where completing the square will be required for us outside of when you learned quadratic formula in section 4.5. I would dearly hope that you would prefer completing the square here and be fond of the method as best as you can, because it is very useful and much more efficient than quadratic formula. When you're set up like this, 1x squared, even linear coefficient. Let's keep going. Let's complete the square. We are in a 1x squared scenario, good even linear coefficient. Let's add the same number to both sides. In this case, negative 4 divided by 2 is negative 2, squared is 4. Negative 2 squared is 4. Add 4 to both sides. This factors down into that x minus 2 quantity squared. Negative 2 plus 4 is 2. Solve. We're going to take the square root of both sides. And you know what? I'm probably going to stop writing this as well. That square root thing, that's what we're doing. So the first time I don't write it, you say, well, how'd you do that? I took the square root of both sides. Root 2 is not a perfect square. So this is plus or minus the square root of 2. And when I add 2 to both sides, you get x equals 2 plus or minus the square root of 2. Here's an exact answer set of your two solutions. They do ask us to round, however, to the nearest hundredth. I got to pop up my calculator software. Give me 1 second. Okay, so we're going to round this thing, and I'm going to do 2 plus root 2 and 2 minus root 2. So 2 plus the square root of 2. And there's symmetry to this. This is one of the reasons why I wish that we solved graphing afterward and talk about that symmetry. But let me write these out. X is about 3.41. So I'm assuming it's easier to just write this out. 0.59, 2 minus root 2. And I probably won't show you the calculator for a lot of these in the future. I'm just showing you what I'm actually computing. Yeah, 0.59 when rounded to the nearest hundredth. So 0.59. So those are the two solutions that we get to that thing when rounded. Wish I just brought home one of my... Remind me to bring home one of my calculators from school so I can just do this by hand a little bit faster. Because pressing those buttons takes longer than I need it to make it. Another non-factorable one, so get the calculator ready. We have x squared plus 2x equals 5. I like the variance in problems. They're all pretty good. They're sticking with evens as long as possible. Now they're diving into some of the irrationals. Let's see where we go from here. X squared plus 2x plus blank equals 5 plus blank. We now complete the square, make a perfect square trinomial. This number's 1. See if you can figure out why that's going to be. And so we add 1 to this side as well. I should mention it now. 2 divided by 2 is 1, and 1 squared is 1. And because 2 divided by 2 is 1, 1 is also that value that goes into here. This is your factored form of the perfect square trinomial. 5 plus 1 is 6. Let's see if we can do this without me writing it. I'm going to take the square root of both sides. That gives me x plus 1 equals plus or minus the square root of 6. So that's exactly what I did. And now I subtract 1 over. So x is negative 1 plus or minus root 6. Very valid, correct answers there. However, when we round, and allow me to just kind of do this on my own, negative 1 plus root 6, I'm getting 1.45 rounded. Positive 1.45. Next one's going to be obviously a negative answer. Negative 1 minus root 6, what is that? Negative 3.45? Negative 1 minus root... Yeah, negative 3.45. Negative 3.45. There you go. I wish they didn't have us round. All right, number 21. Also non-factorable. X squared minus 5x equals 8. And also an odd number. So, here we go. X squared minus 5x equals 8. Let's solve this guy. We are going to complete the square. And here we go. Negative 5 over 2 is negative 5 halves. We square that to get 25 over 4. I'm only writing that so you can see exactly how this goes. Next problem, I will not do this. This is 25 over 4 here. Now, there are two things I got to do. In 8 plus 25 over 4, I got to find a common denominator on top of I got to factor this here. Now, the factoring should be as straightforward as we've seen. It's going to be x minus 5 over 2 quantity squared, like that. And 8 is also 32 over 4. This common denominator practice requires that you multiply top and bottom by 4 times 4 over 4, like that. 32 divided by 4 is 8, so that's how we write it. 32 fourths plus 25 fourths gets you a number. Let's figure out what that is before we keep moving forward. That's going to be 57 over 4. Okay. Now we take the square root of both sides. So let me actually write this part out so we recognize what we're doing on this right side here. Here we have x minus 5 halves. And this side we're on plus or minus. Now the square root of 57, we can do 19 times 3, no perfect squares there, so it's not a, I can't simplify it more, but the square root of 4 gives you 2, which is going to kind of make sense with these problems. We tend to get a common denominator ultimately by the end. Here we're going to get x equals 5 halves plus or minus root 57 over 2, and as they are a common denominator, it's better written as 5 plus or minus root 57 all divided by 2. Get very comfortable with these kinds of answers, folks. This is what appears in quadratic formula all the time. So if you end up liking quadratic formula more, guess what? That's what they look like when they're irrational. Quite a bit of those, or at least the setup. Obviously, this was completing the square, so obviously we got the same answer. I'm just saying that be comfortable with seeing that kind of format quite a bit. Now I got to go ahead and round this guy. Root 57 all divided by 2. And then we can do 5 minus this. So let me just first kind of compute what these are, then I'll write them out. So I'm getting 6.27 and negative 1.27. Approximately negative 1.27. Now, one thing, you know what? I will show you this on the calculator, because what I want you to see is... Oh, there's more on the bottom here. That's a longer page. What I want you to see is how I wrote it. 5 plus root 57 divided by 2, 5 minus root 57 divided by 2. Be very careful with how you write this, especially, you know, order of operations has to factor into here. And I need parentheses around my numerator. See, there's parentheses around the square root, and I close that, but I need another set of parentheses to say this is all on top. 5 plus root 57 all divided by 2, 5 minus root 57 all divided by 2. If I wrote it like this for the minus, and I had that, this is going to be a different answer and an incorrect answer. Only root 57 is now being divided by 2. 5 is just subtracting that. Here's another answer, which is not... It looks almost similar that's for no reason whatsoever. One's positive, one's negative. They look very close for no reason whatsoever. That's just a false whatever that we see there. That's the answer, negative 1.27 and 6.27. Case in point, I don't think this answer is going to look the same. Let's do a plus here and take that out. I think this answer should look... Okay, that one looks starkly different from 6.27. Anyway, the point is, group the parentheses around that numerator, denominator kind of stuff. Hold on. Sometimes my gimbal just goes out of whack. And, yeah, go from there. So, let's keep moving forward. Number 22. And the last one out of this little section, which I'm not saying I wish we did more of those, but if this were more drill and kill and other problems are less drill and kill, well, you know where my mind wants to go. Negative 10. Let's go ahead and complete the square. We get x squared plus 11x plus blank equals negative 10 plus blank. Let's do some mental math. 11 halves is half of 11, and we square that, we get 121 over 4. So we're going to add 121 over 4 to both sides. This factors into that x plus 11 halves squared. Now, negative 10 is also negative 40 over 4. So negative 40 over 4 plus 121 over 4 gets you 81 over 4. Oh, those are good numbers, because I can take the square root of both sides here, and the square root of 81 is 9, and the square root of 4 is 2. So now we'll get x plus 11 halves equals, by the way, that must mean this was factorable, which it totally is, plus or minus, don't forget that, 9 halves. We subtract 11 halves from both sides, and we get negative 11 halves plus or minus 9 halves, or negative 11 plus or minus 9 all divided by 2. Now, these are very nice numbers, and they're rational and all that. I'm not using the calculator for this. Negative 11 plus 9 over 2 and negative 11 minus 9 over 2. This will give us negative 2 over 2, which is negative 1. And this gets us negative 20 over 2, which is negative 10. So, there are those two answers. And listen, this was factorable. You add the 10 over, and all x minus, or x plus 10 times x plus 1. That's what you get. If it's solvable by factoring, I would have preferred it, but we're in a different kind of section here. Okay, number 23, modeling with mathematics. The area of a patio is 216 square feet, and we see a representation with that problem where we have a rectangle of length x feet, or width x feet, and length x plus 6 feet, and the area is 216 square feet. Okay. Let's go ahead and do what? Write an equation that represents the patio and find the dimensions of the patio by completing the square. You bet. All right. So the length times width, x times x plus 6 will give us 216. Let's solve by completing the square. So we have to then distribute. I guess this qualifies. I'm going to distribute anyway. X squared plus 6x equals 216. I don't know if this is factorable. I wouldn't speculate on assuming for any reason why it would be. It could be. It very well could be. But let's solve by completing the square as requested. Leave the 216 on that side. We'll find our own number here, and that number will be 9. That's half of 6 squared. 3 squared is 9. So we're going to add 9 to this side as well in completing that square. And this factors down to x plus 3 quantity squared. Oh, this was factorable. Because 225 is a perfect square. If I take the square root of both sides, I get plus or minus 15. And I subtract 3 over, you get negative 3 plus or minus 15. Now, the only answer that will qualify for us is the positive answer. Negative 3 minus 15 has no business for us. Negative 3 plus 15, however, is 12. And we get that answer for x. They ask us to find the dimensions. Our dimensions, our width will be 12 feet, and our length will be 12 plus 6 feet. So width is 12 feet. Length is 12 plus 6, which is 18 feet. And 12 times 18 must be 216. Sure. I know that 6 cubed is 216. That's the extent of my 216 knowledge. All right, that was number 23. Let's move on to number 24, another modeling with mathematics. Some sand art contains sand and water sealed in a glass case similar to the one shown. I don't see any sand and water. When the art is turned upside down, the sand and water fall to create a new picture. The glass case has a depth of 1 centimeter, which is not shown, and a volume of 768 cubic centimeters, whereas we now have length and width of x and x minus 8 respectively. Write an equation that represents the volume of the glass case. Now, if the depth is 1 centimeter, multiplying by 1 doesn't change the value, which, cool. That's very helpful for us. But volume is still length times width times height. In this case, the height might be our depth or whatever times depth. So with the volume being 768, we can multiply x times x minus 8. This is kind of length width. And then that height is 1. Which don't change, nothing there. And this equals 768 for that thing. Let me pause this to not bother you. Okay, let's hope that works. Times 1 means it doesn't change. So let's just distribute. I think that's part A. So part B, find the thing. Distribute x. You get x squared minus 8x equals 768. Big number, but I'm sure by square rooting some stuff, we're going to deal with it just fine. Let's complete the square. X squared minus 8x plus blank. Half of negative 8 is negative 4. Squared is 16. So we're going to add 16 to both sides, like that. I don't know what 784 squared is. So it's x minus 4 quantity squared equals 784. If I'm to guess, it might be 28. Because, well, if it's a perfect square, it's going to be 28. So let's see. I'm going to actually use the calculator for that. Square root of 784, 28. So x minus 4 equals plus or minus 28. Add 4 to both sides, you get x equals 4 plus or minus 28. I only care about the positive answer. We're going to use 4 plus 28, which is 32. So that's what x equals. Find the dimensions of the glass case. We know that the depth is 1 centimeter. And we are going to find the other part. So the length is 32 centimeters. The width is 32 minus 8, which is 24 centimeters, and that depth is 1 centimeter. So boom, boom, and boom. Oh, I guess the glass isn't the depth, I suppose, right? The glass case, maybe it is, maybe it's not. That's okay. All right, that is number 24. Let's move on to numbers 25 to 32. We solve by completing the square. Okay, so these problems here are quite like the other ones. The difference is, well, there are multiple differences. The difference is we're not set up already to complete the square from step 1. The step 1 might require a few more things. On this first one, we're simply going to subtract 15 to the other side. Here's the deal. And this number is very close to the number that makes the perfect square trinomial. We actually just saw it in this previous problem right here. This number is going to be, where is it? This number is going to be 16, right? X squared minus 8x. We just saw this. It's going to be 16. This is 15. And you know what? If this was 16, some students might subtract it over and not even be none the wiser to the fact they already had it. But this is not the number that gives us a perfect square trinomial. So I'm going to go ahead and kick it off to the side by subtracting it from both sides. Therefore, we can add something to both sides, and this will be that 16 negative 4 squared. So add 16 to both sides. You know what some teachers do? Some teachers even at my school is this. They find out what that number is, and they find out all that they need to add. 16 is 15 plus 1, and then we add plus 1 like that. This is going to give us the same result. I don't go about it that way. I don't find what's missing information-wise. It's another extra math step that I don't need. Or maybe not, I don't know. But anyway, so from here, this factors into x minus 4 quantity squared, and negative 15 plus 16 is 1. We take the square root of both sides, you get x minus 4 equals plus or minus 1. Yes, the square root of 1 is 1. And we add 4 to both sides, and we get x equals 4 plus or minus 1. 4 plus 1 being 5, 4 minus 1 being 3, which means this was factorable. This factors indeed to x minus 5 times x minus 3, and those are the two answers. But they do ask us to solve by completing the square, and that we shall. It doesn't hurt to remind you guys of what is and what is not factorable, such as number 26, which is factorable. X squared plus 4x minus 21 equals 0, so do not be surprised when you get the answers of negative 7 and 3. So let's go ahead and add 21 to both sides because it is not the value that gives us a perfect square trinomial. No, in fact, that number is 4. Half of 4 is 2. 2 squared is 4. Let's add 4 to both sides. This factors into that x plus 2 quantity squared, and 21 plus 4 is 25. We take the square root of both sides, and we get x plus 2 equals plus or minus 5. Remember, we did take that square root. We subtract 2 from both sides here, and negative 2 plus or minus 5 gets you negative 2 plus 5, which is 3. Negative 2 minus 5, which is negative 7. I believe those are the numbers I said. And that's what we got. It's a rather fast process. I'm solving by factoring would have been faster, but all told, if it's non-factorable, because I would have stopped at this step, it's a 4-step process. Quadratic formula. And I keep bringing up quadratic formula. The reason I keep bringing it up is because students like it more because they have a form. They just got to substitute. There's more to it than that. If you have to simplify radicals, if you have to, for some reason, completing the square is a process for which they sometimes have trouble with. All right, very first step I'm going to do here, guys, is I'm going to divide everything by 2. If I can divide by 2, then I will. This gets me my 1x squared. I will not complete the square if that is not a 1. And if I can divide outright, then I will. And I'm going to go, even if I wanted to solve by factoring, which this is not factorable, and if I wanted to solve by quadratic, I would do this anyway. But let's go ahead and now kick that 22 over, subtracting that. And let's complete the square here. 10 divided by 2 is 5. 5 squared is 25. By the way, oh gosh, this is, I'll do it after this problem. I'm going to write by the way. Otherwise, I'll forget to say what I wanted to say. This factors into x plus, why is that blue? This factors into x plus 5 quantity squared. Negative 22 plus 25 is 3. It kind of lends to the fact that this wasn't actually factorable because the square root of 3 is, well, it's irrational. So plus or minus square root of 3, and now you have x equals negative 5 plus or minus the square root of 3 once we factor the 5 over. They do want us to round to the nearest hundredth, so I'm going to get you those two values. Negative 5 plus square root of 3 being negative 3.27-ish, and negative 5 minus the square root of 3 being negative 6.73-ish. So x is about negative 3.27, and x is about negative 6.73. Okay, by the way, I wanted to mention this. Let's say, this is a completely unrelated problem, but let's say I wanted you to solve x squared plus 10 equals whatever, 2, right? Here's what a lot of students will do once they learn completing the square. 10 divided by 2 is 5, and 5 squared is 25. You know, like that. Well, guys, this wasn't 10x. This is 10. This is not the linear term. This is not what you would do. Listen, you can add 25 all you want. It's not wrong. You added 25 to both sides to an equation. You can do that. But this don't factor to x plus 5 squared. This don't have an x in it. And x is missing. So, you know, there's something to that nature. Not only that, but it lends back to the other thing I mentioned before, which is students will skip that step where they say, divide by 2 squared and you add the thing. It's like, no, that turns into x plus 5 squared and we're all good. This is even worse. You didn't even add anything to this side, and let alone you factor this. This is not how this stuff works. So there's just some by the ways that just because a process is in place doesn't mean it applies everywhere. You have to apply it where it applies. It applies when you have a 1x squared, when you have a linear term. the term with the x, you're adding a constant that's going to make this, you're making a perfect square trinomial. Don't forget what your goal is. Why does this factor down to this? Because this is a perfect square trinomial. So, you know, it's these little things that you do with this memorization and finding habits, and you're doing it in wrong places. You really got to acknowledge and recognize what it is you're doing and where. The problem is, like a lot of things, this isn't the book's fault, but just this book section it lives in a vacuum. Everything we're doing here is completing the square, so it's intending to make it happen. Right? It's going to make it clean, and it's going to do it in problems where you're supposed to. They're not going to give you a problem where you solve using square roots. Granted, completing the square is solving using square roots, but where you don't have to complete the square, they're just not going to give it to you. So that's why I'm saying having review problems where you're trying all the other methods and deciding what's advantageous and when you do what is really important. And I hope when we run into a review, they give us a choice to try, or they say solve using all these methods or whatever. Anyway, I can divide all these things by 3, and I'm going to do that. And by the way, when I say divide by 3 and divide by 2, I'm dividing 0 by 2 as well, but it still equals 0. So I'm not just dividing the left side by 3 here. I am dividing the right side by 3 as well. That's what makes this allowed. That's what makes this allowed. I will subtract the 4 over, however, this looks non-factorable, and I'm going to find the number that completes the square as I subtracted 4 over. Keep in mind, I've probably mentioned this a couple times before, but you always add the constant when completing the square because we're squaring a number. It'll turn positive. Negative 6 over 2 is negative 3. Negative 3 squared is positive 9. And we're adding 9 to both sides. This factors at x minus 3 quantity squared, and negative 4 plus 9 is 5. You take the square root of both sides, and we'll get plus or minus the square root of 5 on that side. And we add 3 to both sides, we'll get 3 plus or minus root 5. My favorite answer of that, but they want us to round. And round I shall. Negative 3 plus root 5. And negative 3 minus root 5. All right, negative 0.76 and negative 5.24. Oops. My bad, Joe. Number 29. So far, so good? All right, number 29. I'll fit it right here. Negative 3x squared minus 24x plus 17 equals negative 40. Now, as I divided by 3 last time, let me pause this. If I don't want this to happen. Okay, I'm back. So generally what I do, guys, is I film sometime before bed or before whatever. And so before that, I also eat because these end up being long videos. I eat a lot. So I had, I had like an 18-ounce steak here. And those hiccups are from eating. And that happens quite a bit. If you ever hear me do and hiccups and stuff or little burps, that's what that's from. Anyway, last time I divided by 3 because I could. Everything was divisible by 3. I still had integers. I can't divide 17 or negative 40 by 3. But if my ultimate goal is to get this thing on the other side of the equation anyway, maybe, just maybe, something will be divisible by 3 when I subtract this over. And I'm not completing the square just yet, by the way. Negative 24. No. This needs to be a 1x squared before I do any of that stuff. Please, please, please keep that in mind. If I subtract 17 over, I will get negative 57. And negative 57 is divisible by 3. So I'm going to divide not just by 3, but by negative 3. So I get a positive 1x squared, a positive 8x, and a positive 19. I divided everything by negative 3, and there's that. Now I get to complete the square. Now that it's a 1x squared, and I get to work on it now. So this becomes 16. 8 divided by 2 is 4. 4 squared is 16. And this factors into x plus 4. Quantity squared. 19 plus 16 is 35. Take the square root of both sides, you get x plus 4 equals plus or minus square root of 35. 35 cannot simplify as a radical. That's the one thing that's been missing on these problems, simplifying radicals. 4.1 was all about that. 4.3 barely had any, and this one, or at least even when they did, they said round, like these. And this one's a little void of it as well. I guarantee you quadratic formula problems will do it by the nature of how you do the quadratic formula. We're going to simplify a lot of radicals there before we do our rounding. Negative 4 plus or minus square root of 35, however. And by the way, if I use quadratic formula on this problem, I would have had to simplify the radical too. So just by nature of the problem, it would have happened. So If you don't want to simplify radicals, use completing the square when you can. Anyway, -4 plus square root of 35. I keep saying all these things because people are not advocates of completing the square. There's a time and place, and these problems that I'm doing right now are that time and place. This is when you do it, this is most beneficial. Get used to it, love it for what it is. Okay, so here are my approximations. I'm getting 1.92 and negative 9.92. Okay. Number 30. Yeah, whether you want to divide earlier or later is up to you. These are all divisible by 5, so kind of your call. It's not going to change your result on how things work out. If you want to divide by 5 right here, go ahead. I'll do -5. Just the fact they can all divide by 5. -5, so x squared plus 4x minus 7 equals -6. Again, dividing by negative switches your signs. Doesn't change the fact I'm going to add 7 over here. X squared plus 4x equals 1. Let's go ahead and complete the square on this part 2. As well, I should say. Divide by 2, square it, you get 4, and 4 on this side. This factors into x plus 2 quantity squared. This looks like an example problem. Oh, the example problem was in vertex form, though. Take the square root of both sides. You get x plus 2 equals plus or minus square root of 5. This part's different. And subtract 2, you get -2 plus or minus square root of 5. So I'm done. Yes, I know I'm working fast. I acknowledge it. Pause as you need to. -2 plus the square root of 5. These are, I'm doing the same thing over and again, though. So that's kind of where I'm getting a little antsier. 0.24 is my approximation on -2 plus root 5. And -2 minus root 5, I'm getting -4.24. I probably should have known that. -4.24. It's all symmetry. Numbers 31 and 32 are left to go on this set. Still not halfway done with the problem set, just so you know. 2x squared, what? Same thing. All these are divisible by 2, so I can start that immediately. 2x squared plus 14x plus 10 equals 26. Let's divide all this by 2, and you get x squared minus 7x plus 5 equals 13. I'm going to subtract 5 from both sides, and we are... See, this 14 was even before, and then we find out it's actually not even ultimately, but I'm going to subtract 5 from both sides, and we do get 8, and we do need to find the number that completes the square here. This is going to be one of those fractions. -7 divided by 2 is -7 halves. We square -7 halves, we get positive 49 fourths. So 49 fourths comes on this side as well. 8 is 32 fourths. We've seen that in a previous problem. And we common denominator. So we're going to deal with that, where this factors into x minus 7 halves quantity squared. This is a nice one. It looks like this becomes 81 fourths, and we've seen that before as well. If you take the square root of both sides, we get x minus 7. That must mean this was factorable if we subtracted 13 over. Yeah, that would have been factorable. Square root of 81 is 9, square root of 4 is 2, and I get to add that 7 over. Now I have a common denominator, guys, so this is 7, positive 7, plus or minus 9, all divided by 2. Remember, both of them divide by 2, and we don't need the calculator to do 7 plus 9 over 2, which is 16 halves, which is 8, and 7 minus 9, which is -2, over 2 is -1. So this was factorable, ultimately. Maybe, just maybe, this one also will be as well. We get number 32, where we have, 4x squared plus 12x minus 15 equals 5. Off the bat, not everything's divisible by 4. So let's go ahead and add that 15 over and see what we get out. We will get 20. Good, these are all divisible by 4. Makes life easier for myself. I get x squared plus 3x equals 5. Dividing everything by 4, and let's complete that square. 3 halves squared is 9 fourths. 5 is also 20 fourths, 20 over 4. So remember, this is x plus 3 halves, which gets squared. 20 fourths plus 9 fourths is 29 fourths. As we take the square root of both sides, we have x plus 3 halves equals plus or minus square root of 29, which is a totally prime number, very unsimplifiable, all over 2. I'm waiting for some simplified ones, not here yet. And we subtract 3/2 from both sides, we'll get negative 3 plus or minus root 29 all over 2. They share a common denominator. There's an exact answer set. Rounded, again, we have to be careful and mindful of those order of operations. So I'm going to do open parent, let me show you this type. I'm going to be doing, I cleared everything else, open parenthesis, negative 3 plus root 29 over 2. And notice that I have to close that set of parentheses as well. And I'll do negative 3 minus root 29 over 2. Now, some people might ask, Mr. Robinson, is there a plus or minus button on the calculator? I don't know if there is, but we can only get one output from something. If I write plus or minus, what are they going to give us? 2 answers? Maybe. But what if you put multiple plus or minuses? Plus or minus, plus or minus, plus. No, I don't think there's a function that's going to have that on the calculator, so don't expect that. You got to do the plus, you got to do the minus. So I'm going to get approximately 1.19 and negative 4.19. Just writing that, unboxing that, taking it to go. And that is number 32. And take care of my snifflies. Okay, let's go ahead and move forward. Numbers 33 and 34, we hit our error analysis, which probably means word problems are coming up after this. So, describe and correct the error in solving x squared plus 8x plus 10 by completing the square. Let me guess what they'll do. I have no idea. They might square something wrong. They haven't shown us that. They might not add 16 to both sides. I don't know. Let's see what they do. They don't add 16 to both sides. So, in this problem, they don't add 16 to both sides. The number that completes the square on the left side. In any equation, this is not just completing the square, guys. In any equation, whatever is done to the left side of an equation must also be done to the right side when it comes to manipulating it. That includes when completing the square. So, you know, I mean, look, I subtracted 3/2 from both sides right there. I added 15 to both sides here. It's just that it's not as visible or apparent. It's not as funky looking and it's not as random seeming. Of course, it's not random. It's the number that makes the perfect square trinomial. But it just, you know, it kind of takes on that effect. So let's get to that perfect square, completing the square step, because of course we got to fix it. We got to add 16 to both sides here. Plus 16 plus 16. So they got some answer stuff. Everything else after that's fine. Obviously, that's not the right number. But the answer they got after was whatever. But we're going to get a different answer, just slightly different. We'll get a root 26 here. This factors to x plus 4 quantity squared, and this is 26. Take the square root of both sides, we get x plus 4 equals plus or minus square root of 26. They got the plus or minus part as well. I'm going to guess the next error doesn't show plus or minus. I haven't looked at it, but I don't know. No, actually, that wouldn't... Maybe not, because that has more to do... I don't know. I don't know what the other question's asking. I was going to say the plus or minus probably has more to do with section 4.1 and 4.3 and not 4.4. Okay, they notice how they didn't round these answers, so I'm not going to as well. Exact answers like these are normally, generally fine in what we do. Number 34, describe and correct the error in the first 2 steps of solve. Oh, okay. No, this is a better thing to talk about anyway. So right here, it's cool they added 4 to both sides. They need the quadratic and linear term because they want to add their own constant. Now they did negative 2 divided by 2 is negative 1. Negative 1 squared is 1. They added 1 to both sides. So what's the problem? The problem is this isn't a perfect square trinomial. You want to know why? Because this 2 right here. This doesn't... Tell me what this factors to. I'll wait. It's not x minus 1 quantity squared. What's this 2 doing here? It's not 2x minus 1 quantity squared. No. The problem is that 2 was never taken care of. I can't speak. That 2 was never taken care of. The a value is not positive 1. Or it's not 1. It needs to be a positive 1. It is a 2. In order to complete the square, that 2 must become a 1. 2 must become 1. A 1 either by factoring or dividing the 2 out. That is an absolute must, at least as far as you can't use 2. Definitely can't use 2. It's not a perfect square. It's not the square. So let's correct that. We're just doing the first 2 steps. 2x squared minus 2x minus 4 equals 0. Outright, y'all. I'm going to divide both sides by 2 right now. And we get x squared minus x minus 2 equals 0. Now I'll go ahead and add that other 2 over, which is still irrelevant to this thing. I mean, it's not the number that completes the square. So we got to take negative 1. Remember, that's what this is. Negative 1 divided by 2 is negative 1/2. Negative 1/2 squared is positive 1/4. This is then a number that goes in here. They're not asking us to do anything else, but you know what this is? It's a perfect square trinomial, which factors down to something because it's a 1x squared, and that's what we can deal with for it. So that's the final step and stage in what we do in that. Now listen, if I doubled everything, because listen, you might want to say, well, what is it? Because I can double everything back out. You know what this looks like when it's doubled out? 2x squared minus 2x, just like those, plus 1/2 equals 4 plus 1/2. See, these are ones. This even this, it's not a perfect square trinomial anymore, but when you factor a 2 out is, at least this takes on the form of a perfect square trinomial. The other one does not, and you can see that it's a different, what I want to show is it's a different number. You don't get 1 out. The 1 does not give you the opportunity of a perfect square trinomial. You must first factor out the 2 or divide it. All right, number 35, number sense. Find all values of b for which x squared plus bx plus 25 is a perfect square trinomial. Explain how you found your answer. Well, I happen to know what this will be by understanding my perfect square trinomials, but let's go in a different format here. They've shown you algebraically so. I mean, we can look at it in this format as well. If you divide this by 2, you get b over 2. When you square this thing, you're going to get b over 2 squared. B over 2 squared. So guys, b over 2 squared is our 25. So let's take the square root of both sides right now in this situation, and we're going to get b over 2 equals, don't forget this, plus or minus 5. Now let's double that, and we get, multiply both sides by 2, you get b is plus or minus 10. These are the 2 different values for b. We can have x squared plus 10x plus 25, and that's a perfect square trinomial, or x squared minus 10x plus 25. That's also a perfect square trinomial. It's really working backwards from what we were doing before. If we were dividing a number by 2 and squaring it to get 25, then let's take the square root and double it. But don't forget that that number could have been positive or negative. I'm showing my explanation right here mathematically. I'm not going to write out what it was, but it's the backwards approach of what we've been doing. I'm sorry, that's not 25, that was 35. 36, and this isn't 25, 26 is 36. Number 36, you are completing the square to solve x squared plus 6x equals 12. What's the first step? Well, why don't you just let me complete the square and I'll tell you. 3x squared plus 6x equals 12. My first step that I'm going to do here is I'm going to divide everything by 3. I want to get this into a 1x squared here, so x squared plus 2x equals 4. I'm not going to finish from here, but that's what I'm going to do. Divide everything by 3. They didn't ask me why, but I need a 1x squared. We've kind of gone over that, but I'm going to divide everything by 3. Okay. Now listen, I can do it at all costs, even if 12 couldn't divide by 3, but I must absolutely make that a 1x squared. All right, in 37 to 40, we're going to write the function in vertex form by completing the square. So no negative b over 2 I talk. Then we're going to match the function with its graph. So the vertex will help us reveal the graph plus the sign of the equation. So we're going to start with y equals x squared plus 6x plus 3. Okay, now here's where I do something slightly different from the book in that I don't subtract the 3 from this side. I just move it off to the side. I'm going to complete the square here. There's still a plus 3, and so I'm not going to touch the side with y. I hope you're okay with that. On the same side of the equation, if I add a number, I will also subtract that number to keep balance. Add and subtract on the same side of the equation, whereas in other situations you add to both sides of the equation. Right? This is the same side. So what number goes here? It's 9. 6 divided by 2 squared. So you subtract 9 as well. You're like, well, Mr. Robinson, 9 minus 9 is 0. Well, no, the goal was to make a perfect square trinomial. We're going to factor this guy down. We're just going to combine these two. So this becomes x plus 3 quantity squared inside there, and 3 minus 9 is negative 6. Hey, y'all, this is vertex form. And I would argue that's significantly faster than using negative b over 2a and plugging the values in to then write out the form However, our goal of this was to find the vertex. Now the a value was 1, the h is -3, and the k is -6. The vertex is at -3, -6, and this graph goes upward. So which graph will do this? D. Graph D does that. So when I'm circling D or boxing D, it's this graph. That -3, -6 goes upward. That is number 37. Number 38. Y equals, okay, here's a negative. Here's a new thing we're going to learn. Negative x squared plus 8x minus 12. Couple things got to happen. I'm not going to divide anything, only factor, because anything I do has to affect this side of the equation as well if I divided. So I'm going to factor. I'm going to factor -1 out. Not of all terms, though. This -12 is not involved, and I think that's partly why they add the 12 over. Please keep in mind, this -12 is not a part of the completing the squared process, but I need a positive 1x squared for these two terms. X squared minus 8x. We're going to add something that'll complete the square here. Now, two things got to happen here. Number one, I'm going to subtract what happens here. Number two, that thing that I subtract also needs to be multiplied by this -1. If you weren't here for my lecture portion, you might still not have made sense of it. If you weren't here for my lecture portion, this is kind of what we were talking about. Whatever we add here, we subtract, but we're not just adding this number. This number is getting multiplied by a negative, right? Negative distributes into here. Just like if it was a 2, it would be multiplied by 2. So this number becomes 16, right? This completes this square. So I will also subtract essentially -16. I'm going to add 16 right here. So you might say, well, Mr. Robinson, I thought you said whatever you add here, you got to subtract here. Why are you adding in both? I'm not technically adding 16, right? -16. It's being subtracted. But as far as completing the square goes, inside the factorization, a 16 is being added. Because, as the negative stays outside, we factor this into x minus 4 quantity squared. Now, here we have -12 plus 16, right? Minus -16, which becomes 4. And I don't know if that's more confusing than not as far as how I write it versus how the book will write it. The book kind of just skips the step in saying what you distribute, so I wouldn't say it's any worse. All right, this vertex is at 4, 4, and the graph goes upside down because A is negative, so let's find that. Looks like graph A. Graph A does that trick. Number 39. Y equals -x squared minus 4x minus 2. Once again, we have the listen, we know the graph is going to be B because it's the only other one that's negative, but let's get into that one. -x squared minus 4x minus 2. I'm going to factor the negative out of the first two terms here. -x squared plus 4x, and let's complete the square. As this -2 sits on the outside, we are going to subtract the opposite, right? The -1 here is going to multiply by whatever number goes there. So we are going to, this is a 4. And a 4. So this factors into the opposite of x plus 2 quantity squared, and -2 plus 4 gives us +2. There's the vertex form with the vertex of -2, 2. This graph going downward. That was graph B. That's what we get for number 39. Probably got to take care of that again. Number 40. Probably an easier equation than the last two because there's nothing to factor out in front. Y equals x squared minus 2x plus 4. All right. So x squared minus 2x plus, what number? We're going to add and subtract it and figure that out. This is a 1x squared. We're all good to go. -2 over 2 is -1. Squared is 1. So we're going to get a 1 out of those and factor that guy here down to x minus 1 quantity squared, and 4 minus 1 gives us 3. Here's your vertex form. The vertex itself is at 1, 3. This graph will go upward because of the a value being 1. That leaves us with C. Of course, by process of elimination, that was all that was left, and that is that graph, number 40. At least we're past the halfway mark. That's the only thing I can assure you for problem set. Time-wise, I don't really know. Probably a lot of word problems to go here. Number 41 to 46 will determine whether the quadratic function has a maximum or minimum value and then find the value. Now, the max or min is dependent based on whether the graph goes upward or downward. Finding the value is finding the y value of the vertex. Only the y value. I mean, I'm going to get it in vertex form, but it's all about that k. You know, in your HK stuff. So, same stuff, completing the square, all of that. We just don't need to see the graph that matches it. Y equals x squared minus 4x minus 2. First of all, it's going to have a minimum. Now, the reason is because 1x squared means it goes this way. The minimum is the vertex at the bottom. There is no maximum for a graph that goes up forever. This graph will have a minimum, and we'll figure out what that minimum is shortly. Let's go ahead and complete the square. X squared minus 4x plus blank minus 2 plus blank. This plus blank is the most important part. Honestly, after this, I don't really have much more to do. It's plus 4 on both of these when I complete the square. I don't even need to really write this part. It's all about the negative 2 plus 4, baby. I can tell you right now the minimum is going to be 2, but this comes from doing, if I write vertex form, x squared, x minus 2 quantity squared here, and negative 2 plus 4 is that 2. So this gives you the minimum of 2. It's all about this guy, like I said. All about that guy. So that is the answer. But, you know, I think it's worth just writing vertex form out. You know, it's something where you probably got to get the practice in as well. Factoring these things down. We got to solve those ultimately. But I'm going to keep pointing that out if I can. Number 42, we have y equals x squared plus 6x plus 10. I'm turning all the things in my head here. I already see what it's going to be. It's going to be another minimum as this graph goes upside down, or right side up, I should say, and it's at the bottom. So we're going to complete the square with a, I'm sorry, I got the wrong answer on this previous one. Hold on a second. Give me one moment. Hopefully I didn't do this a lot of times. Okay, I didn't. I was just thinking about this. You don't add 4 here. You subtract 4. So let me do this one more time. That's not a 2. That is not a 2. That is a negative 6. Let's do that again. My bad. So negative 2 minus 4 is negative 6. As I was doing this one mentally correctly, I just realized that that was going to happen. Sorry. All right. Let's go back. X squared plus 6x plus 9. And as this plus 10 moved over, we are also going to be subtracting 9 over here. Did I do that any other time? Let me make sure I didn't falter. I don't believe I did. Minus, minus, minus. We're all good. Okay. I think that's the first time I've ever done that. I think because I just talk so much over these, I don't realize what I'm actually making happen. It kind of comes twofold. Sometimes when I talk, I hear and catch myself in what I say and go, oh, whatever, because I said it, it helps. Sometimes when I talk, I'm not thinking about what I'm writing. That's why you see so many handwritten typos all the time. Anyway, your minimum value here this time is at 1, and this one I can assure you of. So that is 1. Remember, it's just the y value. It's the y value of the vertex. Number 43. We're going to feature a maximum this time because the x squared is negative. That means the graph goes upside down. It hits some top, but it's still all about that y value, that k. This will take a little more work as we're going to have to factor out that negative 1 from the first two terms. So y equals, factor the negative out. You have x squared plus 10x, and let's go ahead and complete that square right here. Whatever we add there, we're going to have to subtract out of, making sure that you multiply by the negative. That appears out in front like so. 10 divided by 2 is 5. Squared is 25. So we are, as little as this part matters, we're going to factor that down in x plus 5 squared. Now we have negative 30 plus 25 minus the negative. Negative 30 plus 25 is negative 5, and that negative 5 is the answer. We have a max at negative 5. This graph does go upside down from that. Number 44. Kind of glad we're not graphing on top of it. Number 44. Y equals. Now, I would have happily gone back to chapter 3 and done these things by completing the square, but that's not the order that they presented them. A lot of books, for some reason, do this way. Y equals negative x squared plus 14x minus 34. We can factor the negative outside of there. We get x squared minus 14x. Let's find out what goes there. As negative, negative 34 subtracts the negative version of that number. This will be 49. As you can see, 7. Negative 7 gets squared, so 49 here. The vertex form is going to be x minus 7 quantity squared. Outside of that is a negative. And negative 34 plus 49 is, I think, 15. So plus 15. This is another max because of how this graph goes downward. Getting a top vertex value of 15 based on the k. Turn this page, we got 2 more of these. Number 45, we got f of x. Going from y to f of x, that doesn't change nothing. F of x equals negative 3x squared minus 6x minus 9. Now, I don't know how many other problems had. They didn't. I can't divide everything by -3. I can restoratively perhaps do it, multiply everything by -3 once again, but you have to factor the -3 out. Remember, this is not 0 on this side, so this side would get affected, but you can factor the -3 out of, once again, just the first two terms. The last term is its own thing. As we subtract whatever over here, it's going to be multiplied by that same -3 that's right out here. So 2 divided by 2 is 1, squared is 1. So we're going to multiply 1 by -3, subtract that result. And of course, we're all about finding that max or min. This will be another max, x plus 1 quantity squared. -9 plus 3 times 1, so -9 plus 3 is -6. This will be a maximum of -6. As the graph is still upside down because that is still a negative. And then number 46 looks like a minimum again. We haven't seen one of those in a while. Although it's not negative, we still will have to factor out that 4. And remember, it's not dividing by 4 that I'm attacking here. It's just factoring it out of the first two terms, not the constant. The constant is left to add with or subtract whatever multiplies. Factor the 4 out of here, you get x squared minus 7x. Looks to be a fraction version of something. 32 is going to subtract some number that will be multiplied by 4. Remember, 4 multiplies by this number here. Don't forget that. -7 halves gets squared to get 49 fourths. And we're going to multiply 4 by 49 fourths. The perfect kind of number you want to multiply by 4. 4 divided by 4 is 1. You'll just be left with a 49 there. So that 4 and that 4, skadoosh, they're gone. So as far as vertex form goes, we're going to get x minus 7 halves squared. Weird x value for the vertex, weird h. But 32 minus 49 is -17. Okay, kind of a weird y value, or a weird k. But that is our minimum. Minimum of -17. It goes upward from there. It's a tall stretch. So I imagine it hits that x-axis pretty fast. Okay, number 47. I'll be honest, unless we're doing anything on completing the square, I don't think these really have to do with completing the square. But let's go ahead and answer them. I'm not going to copy down the... Well, I might have to for our sake here. Yeah. Let's copy down. I'll do a rough sketch of the graph. Y equals, because it's not to scale, x plus 8, x plus 3. All right, could this graph represent that function? Yeah, it definitely doesn't have to do with completing the square. We're asking kind of a couple things here. This is factored or intercept form, and these x-intercepts would be ideally, on this portion, the x-intercepts would ideally be -8 and -3, and this graph would go upside down because the negative. So this graph goes upside down. Could this hit -8, -3? Sure. They're on the negative side of it. Yes. Now my explanation is in what I provided over here. These are the reasons why this could conceivably be it. I don't know the scale of this thing, so as long as it hits negative x-intercepts and it goes upside down like that, sure, absolutely. Number 48. Y equals x minus 5 quantity squared. Now I see this as vertex form. And vertex form such that my h is 5 and my k is 0. I gotta sneeze. Let me just pause in general. Okay, sorry. I just sneezed and drank water. All right. Let me just draw this out. Okay. So there are some things of this that could make some sense for this answer, but does it fully work? This looks like vertex form for me, where my h is 5 and my k is 0. And this graph would go upward because the a would be positive. So it makes some sense it goes upward, that it hits the x-axis on the vertex. But this says 5, 0. This will be at -5, 0. Remember, it's an x minus h, so you kind of take the opposite of that. So no, this couldn't be that, because the vertex would be... If it was the other side, yes. Because it's that side, no. Or if this is at x plus 5, yes. Again, not really anything to do with completing the square. Maybe they give us one in standard... No, there's no completing the square here, really. Just keep moving forward. Number 49. I think they're just talking about maxes and mins of vertexes. Y equals 1/4 times x plus 2 quantity squared minus 4. Once again, we are in vertex form for this. Let's look at the graph that would match up. Potentially match up. So there's that drawing the graph. Let's investigate. This vertex would be at -2, -4. -2, -4, and this graph would be going upward with a compressed stretch factor, but we none the wiser to that. Yeah, -2, -4 though, right? This thing seems to be at maybe 2, -4 at a possibility. This is another no. For that reason, the x value kind of in the wrong spot for the vertex. So probably not looking at the right version of that. Number 50. Let's take a look. Y equals -2 times x minus 1 times x plus 2. Now, as much as these aren't to scale, it is important to note that the way that they drew this, they do have the negative x-intercept that's hit farther out than the positive y-intercept that's hit, so or x-intercept that's hit, something like that. That matters to me as far as when I talk about scale. At least we can consider all things on x at the same scale. This is closer than that. That being said, the x-intercepts that this graph would feature based on the equation is 1 and -2, and this graph would go downward because of the -2 that you see right there. 1 being positive is closer to 0 than -2 is, so this makes sense, and this graph goes upside down. Yeah, I can see this thing work. That being said, once again, if this was the other way, if this looks like this on that side, I would say no. I would say no just because scale basis, right? Just because the 1 is closer and is positive. So that seems to make sense to me of the way that it's written. Let me take care of some more. Snifflies. These are post-sneeze sniffles, kind of an aftershock, if you will. All right, number 51 and 52. Let's determine which of the functions could be represented by the graph. So there's a lot of, wow. Oh, I see. Just these 4 for this one. It still has nothing to do with completing the square, which is fine. Explain. I'm going to do it out loud. I'm not much sure how I'm going to do it here. So it's an upward facing graph. I'm going to rule out this -1. G is gone. The vertex is -2, -3, sure, maybe. -3, -2, sure, maybe. -2, -4 x-intercepts, sure, maybe. The only, and you might state, well, Mr. Robinson, you were talking about how, I don't know if this could be, oh, I'm sorry, that's not -2, -3, that's -2, 3. I'm sorry, that one's off. These are very possible. The y's could be scaled differently from x as well. We have no idea what that's going to be, but these two makes sense because x-intercepts, let me just write out why this would be. On this side, vertex of -3, -2, graph faces upward. We're all good there. Graph faces upward on this one as well. And -2. Sorry, these are x-intercepts now. -2 and -4. So that makes enough sense to me to justify that those are possible. So f and m, let me just write those. F of x and m of x. They might just put f and m and you're good. All right, number 52. Same investigation using factor, I call it factor form, but intercept form and vertex form and such. It's a negative graph, so rule out any positives such as that one. Let's look at the vertexes and intercepts and such. 2, 9, sure, that can work out. 2 and 6 as x-intercepts. No, they can't both be positive. One of them's negative, so rule out P. I'm assuming these other two are then good. Negatives here. 5 and -1 as x-intercepts. Yeah, so these two seem to work out. It seems like they always rule out 2 and they leave 2 left. So x-intercepts of 5 and -1 seems to satisfy that with a downward-facing graph. This also being a downward-facing graph, and the vertex is at 2, 9. Yeah, so R of x and n of x. So R of x and n of x. Normally I'd copy down the problems, but doing the work over on this side seemed to make the most logical sense. All right, number 53. The function h of h equals -16t squared plus 48t represents the height h in feet of a kickball t seconds after it's kicked from the ground. So ground level means there's no initial height. Makes sense that there's no constant value. So h equals -16t squared plus 48t. Let's find the maximum height of the kickball, find and interpret the axis of symmetry. We need both parts of the vertex. The maximum height of the kickball is basically your k. The x equals h is finding and interpreting the axis of symmetry. So we're going to, it's completing the square section. We're going to do that. I need to factor a -16 out of here first. Not divide, but factor. And we get -3t inside of there. So we're going to complete the square inside of here. Keep in mind, whatever we add in here, we will subtract out here. Note it, I gotta sneeze again. Okay, sorry, I'm back. Whatever I add in here, I subtract in here, provided that I'm multiplying it by the same -16 that I factored out of there. So negative 3 halves squared is 9/4. So this will be a 9/4 here. And this will clean up. That'll be fine. So let's write the whole vertex form. This will be t minus 3 halves quantity squared. Now, 16 divided by 4 is 4, and 4 times 9 is 36. Subtracting negative 36 means we're adding 36 there, so plus 36. Here's the vertex form. So part A, maximum height of the kickball. Max height, 36 feet. That's the top of the vertex-wise. Part B, find and interpret the axis of symmetry. Axis of symmetry is t equals 3 halves. Now, this means that 1.5 seconds after the kick, we reach maximum height. Now, the book was doing something a little bit different. I can say it out loud, and I think this might infer that, of course, as well, or this might imply it, you might infer it, which is that reaching a maximum height means it has to come up to it, and then after that, it goes downward, right? So they were kind of saying it's increasing to the left of this number, and it's decreasing to the right of that number. I mean, to me, that's talking about things outside the axis of symmetry. This is explaining the axis of symmetry in and of itself, I guess. So both of those kind of work for me. But I think that this also implies that, or we can infer that. Number 54, you throw a stone. You throw a stone from a height of 16 feet, I guess above water, with an initial vertical velocity of 32 feet per second. And here's a function that represents that. So this function seems to make some sense. The acceleration due to gravity is this component. Here's your initial velocity component, and here's your initial height component. Find the max height, find and interpret the axis of symmetry. Same stuff. Difference is we now have this constant right here, and when we factor this out, we get a negative 2t to play with, which is much nicer because it's a clean, even number. Now, plus 16 is outside here, unaffected by that negative 16, but when we subtract this number from here, it will be multiplied by that same negative 16 we got outside there. This is a 1 that completes that square, so we will be adding 16 times 1. We'll be adding 16. So we're going to get negative 16 times t minus 1 quantity squared plus 32, it looks like. There's your vertex form. So the maximum height of the stone, max height is 32 feet. And then the axis of symmetry, t equals 1, tells you that 1 second after your throw, the stone reaches maximum height 1 second into throw. 1 second into throw, after thrown or whatever. It increases, reaches the height, and decreases. That doesn't mean it hits the water 2 seconds after, because it starts above the water. So it takes longer after that. All right, number 55. Modeling with mathematics. You're building a rectangular brick patio surrounded by a crushed stone border with a uniform width as shown. You purchase patio bricks to cover 140 square feet. That's the inside. I'm going to copy and paste this thing over. Find the width of the border. Okay. I have to clear up sniffles probably here in a second. And I got hiccups. I'm just full. It's not a good time of the year. When I do softball stuff, environmental stuff outside is causing allergies up the wazoo. The steak is causing the hiccups, but the sneeze, different story. All right, so we have this thing right here. They talked about patio bricks to cover 140 square feet. So we want the inside to be 140 square feet. The outside, 16 times 20 is its own thing, but this is X feet over, X feet across, etc. So when we are dealing with this 20, it's that whole bit. So this inside bit is 20 minus those 2 X's. There was an example like this in the example set. And then 16 minus 2 X's here. The reason why I say 2 X's is there's an X on top and an X on bottom. So we subtract those two, and we're kind of dealing with that. So when we multiply those things together, they said find the width of the border. The width will be the, I guess, the smaller one. We got to solve for X, do 16 minus 2 times that X, and get the answer. But that comes from doing an area. length times width equals 140. That's our setup. So we got to FOIL this thing, right? We got to do 320 minus 40x minus 32x plus 4x squared equals 140. From here, well, I'm probably going to divide everything by 4. I could do it right now. Let me rewrite this first. 4x squared minus 72x. I'm just go ahead and subtract the 320 over now while I can, or while I was negative 180, not negative 280. Negative 180. And let's divide everything by 4. We're going to solve by completing the square, right? So x squared minus, I know this, 18x equals, I know this, 45, negative 45. Totally factorable, by the way, but that's not our goal. We're going to do x squared minus 18x plus a blank. 18 divided by 2 is 9. 9 squared, negative 9. Negative 9 squared is 81. So we're going to do negative 45 plus 81 as well. This factors into x minus 9 quantity squared. Negative 45 plus 81 is 36. Take the square root of both sides. X plus 9 is plus or minus 6. Add 9 to both sides. You get 9 plus or minus 6. Now, I'm going to check both of these and see which one kind of applies best. 9 plus 6 is 15. 9 minus 6 is 3. 15 won't qualify for this. It'd be way too large to compensate for what we're doing here. 3 seems to be the one that kind of makes sense for this answer bit. So when it comes to the width is going to be 16 minus 2 times 3. See, if I had 15, 16 minus 30 would give me a negative number. 16 minus this works out just fine. So the width is 10 feet. To confirm everything works out, 20 minus 6 would be 14, and 14 times 10 is indeed the 140 that we would have gotten. So there's a 10-foot width on that guy. Give me a second. Okay. Okay, number 56. All right, you are making a post. Ooh, those are small little widths. Let's kind of get this ready to go in case we got to use it. You're making a poster that will have a uniform border as shown. So the part in blue is where that X is kind of coming from, okay? I got to figure out whether the 22 is part of the... it doesn't look like it is. The total area of the poster is 722 square inches. Find the width of the border to the nearest inch. Hold on. Okay. Find the width of the border to the nearest inch. So it looks like based off this, 22 just kind of ends there. It's the white. It's the white. It's the 28. That part is there. So X is both ways. X is here and here as well. They say equal width, so that's also X. So we're dealing with like a 22 plus 2X there. 2X is, or 2, I'm going to say 2X plus 22. I'm not kidding. I'm not going to kid myself here. I want it in standard form. 2X plus 22 on that guy. And then this one is clearly 28 plus 2X, or 2X plus 28 on this guy. Total area of the poster is 722 square inches. So we're going to have 2x plus 22 times 2x plus 28 equals 722. Also might have to use a calculator, and I have to stop my hiccups. Okay, moving forward. We're going to go ahead and distribute this thing here, and we're going to get 4x squared plus 56x plus 44x. That's 100, so plus 100x. I don't know 22 times 28, though. Oh. It's 25 plus 3 times 25 minus 3, which is 625 minus 9, which is 616. So plus 616, there we go, equals 722. Difference in 2 squares paid off. Okay, so 4x squared plus 100x, we're going to complete the square, so I'm going to subtract 616 over. I think that's 106, which is unfortunate because... Let me make sure that 22 times 28 is indeed that. It should be. 22 times 28. Yeah, 616. The unfortunate part about it is 106 doesn't divide by 4. Now, I can still divide by 4. I deal with a fraction, and there's really no problem with that. Me being what I do Do I divide or do I factor? I think, no, I do divide. I said I don't, but I do. Divide at all costs, right? So we're going to divide everything by 4 here. I said earlier that I factor. I only do that when it's a y equals equation, but you divide at all costs. X squared plus 100, plus 25x. I might factor, but that's okay. Plus 25x equals, now 106 over 4, I'm going to reduce to 53 over 2. Okay, now we still got to complete the square. We get x squared plus 25x plus blank equals 53 over 2 plus blank. 25 halves squared is 625 over 4, and this is 625 over 4. This is going to be a pretty, I hope I didn't mess up writing a number. The total area of the poster is 722 square inches with a uniform border. I assume the border is part of the poster here. So this factors into x plus 25 over 2 quantities squared. Pretty ambitious problem, especially when I squeeze it in here. 53 over 2 is 106 over 4. Maybe I should have left this as 106 over 4. Because we're going to combine it with this. So 106 over 4 plus 625 over 4 gives us 731 over 4. Okay. Yes, that's to the nearest inch, so it's going to be probably some irrational stuff. Take the square root of both sides. We get x plus 25 over 2. I imagine that's irrational. I'm just going to leave it. Square root of 731. Square root of 731 divided by the square root of 4 is 2. So 731 over 2, plus or minus, by the way. So x is negative 25 plus or minus root 731, all divided by 2. They do have a common denominator. Now, I'm probably going to be using the plus because that'll get me a positive x. The minus will keep it negative. So let's just deal with negative, I'm using my calculator, negative 25 plus the square root of 731. All divided by 2. I don't think I made a mistake in any of the math stuff. I know I did some things mentally, but I did double check that one calculation, which was good. I'm only going to do the plus, so forget the plus or minus. And we're looking at 1.018, so 1.02. That's the x part. Now, they said to the nearest inch, ultimately, so this is going to be closer to 1. But they said find the width of the border. The width is 22 plus those two things. So width is 2 times 1.02 plus 22. Listen, they said to the nearest inch, so 2 times 1 is 2, plus 22 is 24. 24 inches about 24 inches. That's the width of that thing. I could double check this. If I did 24 times, basically 30. 24 times 30, how close is that to 722? Pretty close, it's 720. And the fact that we did some early rounding just shows that, yeah, it would probably get there when you multiply it all. So that seems to work. Pretty long problem, all told. I didn't expect that. I expected it a lot like the previous one. All right, in exercises 57 and 58, find the value of x. Round your answer to the nearest hundredth if necessary. Okay, so on this first one, number 57, we have a triangle. Let's copy and paste these guys here. Less work for me to have to do. So copy and paste. All right, this area is 108 square meters. Okay, area of a triangle is doing 1/2 base times height. So when I take 1/2, I'm gonna write the height first. Height times base, I get 108. I'm gonna multiply everything by 2. I need a 1x squared anyway, and I don't want to deal with that. So I got x times x plus 6 equals 216. Wasn't this the same number? Hold on a second. Hold on a second. Hold on. Wait, did I go too far? No, I don't think so. I don't want to do more work than I have to do. Didn't we already do this? These shenanigans. Look at this. X times x plus 6 is 216. Hey, we solved this before. We got 12. Should I stop? 12 and 18. Do they know that they did this to us already? Well, we're doing it again. If you didn't see it the first time, you get to listen. You might have a different problem set than somebody else. We did this stuff before. Okay, anyway, I'm going to distribute this. I get x squared plus 6x equals 216. We get to now complete the square. X squared plus 6x plus 9 equals 216 plus 9. If I go too fast, tough nugs already did this problem. This factors into x plus 3 quantity squared equals 225. It wasn't the same problem, but it was the same equation. Square root of both sides, you get x plus 3 equals plus or minus 15. And subtract 3 from both sides, you get negative 3 plus or minus 15. Now, solving for a physical thing here, we're going to do negative 3 plus 15, which is 12. What do they want? Find the value of x. X is 12. Remember, we are not going to use the negative answer for this physical property here. Okay, number 58. Don't make me repeat a problem I already did. I want to teach something new to you guys. Number 58. We have a rectangle. I can draw that. Or I can make that work. Right angles tell you it's a rectangle. That means we can use base times height to find its area. So we have 2x plus 10 inches and 3x inches here. And the total area is 288 inches, square inches. We're going to come up with x. So base times height, 3x times 2x plus 10. This looks like a new problem, equals 288. Let's distribute the 3x into these guys, and we're going to get 6x squared plus 30x equals 288. Can these divide by 6? These can. Can this? Yep. 48. 48. So you can divide everything by 6. You get x squared plus 5x equals 48. This is where completing the square can also happen. 5 halves squared is 25 fourths. So we're going to add 25 fourths to both sides. 48 is also 192 fourths. So 192 fourths. And we're going to add that over. This factors into x plus 5 over 2 quantity squared. And 192 plus 25 is 217. So we get 217 fourths. And we get to take the square root of both sides. I don't imagine 217 is simplifiable. I think it's a prime number. So we get x plus 5 halves equals plus or minus root 217 over 4. They did say round if necessary. Excuse me, over square root of 4, which is 2. And I'm going to subtract 5 halves from both sides, and we get negative 5 plus or minus root 217 all over 2. We are going to stick with the plus version of this. So let me take away that minus version and solving for x. We don't find the x's that will be positive for this result here. So negative 5 plus square root of 217 divided by 2. I'm getting 4.865. What did they say to round to? Nearest hundredth. So x is about 4.87. Yeah. No, and I don't have to say inches. It's already used in the expression for here. They just said solve for x. Okay. Number 59 to 62, solve the equation by completing the square, round your solutions to the nearest hundredth if necessary. I guess these are trickier versions now that they have fractions. Actually, these might end up being better than the other ones. The first step might sound scary or it might look a little daunting, but you just got to find the things. I'm going to divide everything by 0.5. That's multiplying by 2. So if I multiply everything by 2, I get x squared plus 2x minus 4 equals 0. The problem looks great. I don't know what we're complaining about. So let's add 4 to both sides and we complete the square meanwhile. That's a 1. This factors into x plus 1 quantity squared equals 5. Now listen, at this point, guys, I'm going to go fast. I'm not teaching what we've already done a bunch of, in the sense that if there's something new I'll bring up, I will. Now it's solving problems. That was new, so I taught it. Subtract 1 from both sides, that equals negative 1 plus or minus root 5. I'm not a fan of rounding to these hundredths, though. I'll tell you what, that's a buzzkill in my tempo. Negative 1 plus or minus square root of 5 gets me 1.23. Excuse me, 1.24. X is about 1.24. And minus, I assume, is negative 3.24. Whoops, I hit the wrong button. Negative 3.24. I should just go off my assumptions because they've been right so far. Negative 3.24. Okay. Number 60. 0.75x squared plus 1.5x equals 4. You know what might be better for us to do rather than just me kind of telling you, hey, it's easy, you just do this. And there are a lot of ways you can go about this. Listen, I can multiply everything by 100, make it 75x squared plus 150x equals 400, and then find what to divide by after, which is totally, that's valid, that's legit, that actually works a lot. And I might do that for a future problem. But let's convert these to fractions. I think that kind of better shows what it is we got to do. This is 3/4 x squared plus 3/2 x equals 4. And maybe that's something, maybe you don't know what those fractions are, I understand. But if I multiply everything by 4, this will take care of my needs because 4 can divide by 4 and 4 can divide by 2. So 4 times 3/4 is 3, 4 times 3/2 is 6, and 4 times 4 is 16. Now, not everything here divides by 3. The 16 doesn't. Let me show you the other form of what I would do sometimes here. Instead of writing over 3, I can factor the 3 out on this side. And then when I complete the square, I do the same thing as I did when it was y equals. I add something on this side and multiply it by 3. I'm good on that front. That's good for me. I honestly think this is how I do it. There's still something that comes about here. We're not quite done after this, right? Complete the square. That's a 1. 16 plus 3 times 1. I do believe this is how I do these problems. And you know what, it's kind of bizarre that I write it this way. I should probably write the parentheses on this number and not on the 3, but I've never broke that habit. I probably should. This becomes x plus 1 quantity squared, and 16 plus 3 is 19. But here you have to divide by 3, right? We've solved problems using square roots before. We got to divide both sides by 3 now before we move forward in 19/3. Now, square root of both sides here. This is the first time that we actually get to do something in terms of simplifying radicals. It's kind of bizarre that we didn't get to do it before. This is root 19 over root 3, and I want to rationalize this denominator by multiplying top and bottom by root 3, which gets me plus or minus root 57 over 3. That's a form of simplifying. There wasn't a perfect square factor inside, but we had to rationalize a denominator. Now I subtract 1 from both sides. Now all this stuff might be a little superfluous for what they ask. They said round your solutions to the nearest hundredth. I want to give you the form of the answer that you would get in quadratic formula, the one that would be very apparent to this. I subtract 1 and I get this, but here's the thing. They're all about common denominators. -1 is -3/3, so I can write this as -3/3 plus or minus root 57 thirds, and this would be a good exact answer. This is the kind of answer that we see. Photomath would show you this, I assume. But this is the kind of thing that you would want to see as a final result there. Simplifying radicals, getting a common denominator. So there are 2 answers to this thing. Let's come up with what they are. Square root of 57 divided by 3. And we get 1 point, so let's see, about 1.52 and -3.52. Of course, I should have looked harder at those numbers, and I think I would have figured that out. Okay, that's number 60. Okay, number 61. Now, these are fractions, so this helps us. 8/3 x minus 2/3 x squared equals -5/6. If I multiply everything by 6, I will clear out my fractions because 6 can divide by 6 and by 3. So here we are going to get 6/3 is 2 times 8 is 16. So 16x minus, same thing, 6/3 is 2 times 2 is 4. 4x squared equals, and this is -5. Excuse me. I'm going to get my x terms positive. I'm going to add this. I get 4x squared minus 16x equals +5. Basically, standard form, change all the signs. Let's get this positive. Let's just get that out of the way. I'm going to factor that 4 out again. I think this is what I haven't done this form in a while, and I think this is what I would do. I won't divide by 4. Instead, we're going to add 5 plus. It's basically the same thing as I would do if I was using vertex form. Like that. So this is a 4 here, and 4 gets multiplied by that 4 here as well. So this factors into x minus 2 quantity squared, and this is 5 plus 16, which is 21. And we get to divide that by 4. Divide both sides by 4. We get x minus 2 quantity squared. Whoops. X minus 2 quantity squared equals 21 over 4. Oh, something happened here. Hold on. You see how this is just a mouse now instead of the thing? What? How did that cause that? Can I get my thing back, please? Ah, shoot. I have to figure out what just happened here. Let me finish this problem with this one. Take the square root of both sides. This looks weird to write with. X minus 2 is plus or minus the square root of 21 over square root of 4 is 2. Now we get to add 2 to both sides, and we get 2 plus or minus square root of 21 over 2. And this is hard to write with. Like I said, 2, let's get a common denominator. That's 4 over 2. So 4 plus or minus root 21 all over 2. Like so. That's an exact answer. Let me figure this thing out. So the pen shows up again. Okay, so basically I had to restart my program here for this to show up properly. Okay. Anyway, I got 4 plus or minus root 20 over 4. Again, 4 over 2 is 2. Got a common denominator. Root 21 cannot simplify, so we leave it like that. But let's get some exact answers out for you guys. So 4 plus the square root of 21 over 2. And 4 minus that. Let's get those out first, and then I'll write them. So that is 4.29 and negative 0.29. Okay, those are 9s. Okay, 61. All right, 62, last one from this set. Kind of winding down, which is nice. Unless all these are big critical thinking problems later. 1/4 x squared plus 1/2 x minus 5/4 equals 0. Excuse me. If we multiply everything by 4, we get x squared plus 2x minus 5 equals 0. X squared plus 2x equals 5. And we're going to add 1 both sides, which completes the square. This factors the x plus 1 quantity squared, and here I get 6. Sorry, I'm trying to take care of hiccups right here. I don't want to keep pausing. Take the square root of both sides, we get x plus 1 equals plus or minus the square root of 6. And subtract 1, x is negative 1 plus or minus the square root of 6. Let's calculate and not talk for a second. Think of something scary. Think of something scary. Oh, let's see. Oh, a student messing up, completing the square when they go. Oh man, I guess that wasn't scary enough. Those are the approximations. I'm gonna pause. Why does the holding your breath technique or while drinking water work for hiccups? I'm gonna look up the science on that. Oh, it's ChatGPT. I think that's the go-to for why that works. No WebMD. All right, number 63, problem solving. The distance d in feet that it takes a car to come to a complete stop can be modeled by d equals 0.05 s squared plus 2.2 s, where s is the speed of the car in miles per hour. A car is 168 feet to come to a complete stop. Find the maximum speed at which the car can travel. So based off whatever the speed of the car is before it starts braking, it sounds like this is its slow up speed. 160. Okay, so we're gonna figure out what speed gets you 168 feet to need to stop at, or what speed you can be at. Still have that. So we're gonna set. This is a 5, and that's an s. S squared plus 2.2s. They always challenge me on that. So d is 160. Let's write that down here. So d is 168. That's the distance. So we'll do 0.05 s squared plus 2.2 s equals 168. It's a problem like this where it's better that I do that multiply by 100 thing. This will shift decimals 2 places over. So if I multiply everything by 100, I will get 5s squared plus 220s equals 16800. I have no fun way of saying that otherwise. But now we can divide everything by 5, and I think that also will pan out for me in a good way. So we get s squared plus 44s, I think, equals... And then I don't, what is that? 16800 divided by 5 That's an 8. I need a 5. 3360. 3,360. All right, let's complete the square here. S squared plus 44s plus blank equals 3360 plus blank. 44 divided by 2 is 22. 22 squared is 484. That's knowledge I got for you, but I'm going to have to use a calculator on this side for something at some point. This factors to s plus 22 quantities squared. Might as well just do it here. Plus 484, because I'm going to have to take the square root of both sides and get the number. So 3844. 3844. Let's take the square root of both sides, and let's see if this actually has a perfect square in mind. I have no idea. Square root of this number? Yes, it is. 62. So plus or minus 62. Great. Makes me feel like I'm doing the problem correctly. So s equals negative 22 plus or minus this 62. And of course, we're just going to be talking about positive speeds. So we're going to do negative 22 plus 62. So that's going to be 40. So 40... Is that miles per hour? 40 miles per hour. 40 miles per hour is the speed where I can have a stopping distance of 168 feet. Well, not in my Honda. All right, number 64. During a big air competition, snowboarders launch themselves from a half pipe. I might need some room for this. This is a lot of words. Let's see. Snowboarders launch themselves. Okay, I see it. This is a snowboarder. Snowboarders launch themselves from a half pipe, perform tricks in the air, and land back in the half pipe. The height of a snowboarder above the bottom of the half pipe can be modeled by this. I don't know if you guys know what a half pipe is, but it's the, you know, for like Olympics. Like, here's like us looking at it from the side. The snowboarder kind of goes up. Whee! Yeah, I'm doing tricks on the snowboard. Yeah, I have no idea. But here's the bottom of the half pipe, right? So they can be, that 16.4 models how far they are for, like, above the ground, above the bottom. So it can be modeled. I'm gonna keep that drawing. It's kind of fun. Can be modeled by. They kind of drew one. Theirs probably looks better. All right. H equals negative 16t squared plus 24t plus 16.4. T is the time after the snowboarder launches into the air. The snowboarder lands 3.2 feet lower than the height of the launch. How long is the snowboarder in the air? So I'm guessing I just need to substitute 3.2 into here. How long is the snowboarder in the air? Round your answer to the nearest tenth. So let's do 3.2 equals negative 16t squared plus 24t plus 16.4. You know, I'm not as compelled to have to say, hey, let's multiply by this and that, because if this side's a decimal, that's fine. It's just about this part that if I need to factor something out, I will. So let's write this on this side for now. Let's subtract 16.4 to the other side, and we get negative 19.6. Negative 19.6. Now when I factor out negative 16, I'm not going to divide. I'm just going to factor out here. And I get t squared minus, and you factor that out, you get 3 halves. I could say 1.5. I'm sure decimals are going to need to apply somewhere, but I just need to know what my number is, and I might not know if I don't write this way. Negative 19.6 plus negative 16 times whatever's going to happen there. So, yeah, you know what? I can use decimals. I'm good on this one. 1.5 is the number that comes out of that when I divided the 16 out, factored it out. And 1.5 squared is 2.25. So I'm going to add 2.25 times negative 16. Plus, negative 16 times 2.25 is a clean number as well, of which I don't know what it is, but I just know that that can multiply. So this is negative 16 times t minus, what's half of 0.5? Oh, wait a second. I did this wrong. Hold on. Go back. See, this is why I need to use fractions. Okay, let's do this again. 3 halves. 3 halves. The half of 3 halves, like this. When you divide this by 2, half of 3 halves is 3/4, or negative 3/4. And then you square that. There we go. So 3/4 squared is 9/16. See, I knew that I needed something. I needed more help from this thing. I need my fraction version, y'all. This is still 1.5 though, but we need half of it, which is 0.75. So That's 0.75. T minus 0.75 squared. I know I'm doing a lot of this mentally, and it might not make as much sense to you. I got to process it in a way that makes sense to me if I'm going to teach it. Negative 16 divided by 16 is negative 1 times 9 is negative 9. So negative 19.6 minus 9 is negative 28.6. Now we divide that by negative 16. This is where it can get a little funky. So T minus 0.75 squared. What are we answering? How long is the snowboarder in the air? So we got to divide that. We got 28.6 over 16. I want to see if there's any merit. Oh, we get to do square roots. Okay. You know what? I'm bringing the fraction back. The 28.6 is for me anyway. I'm bringing the fraction back. I'm going to take the square root of both sides, and the square root of 16 is 4. So T minus 3/4 equals plus or minus root 28.6 over 4. Normally that kind of thing's not okay with me to have a square root of a decimal inside of there when I want exact answers. But we're not going to get the exact answer in the end. I just want a fraction. I don't want a decimal with a fraction. And I don't want this to be some weird rounding thing. So 3 plus or minus root 28.6 over 4. I mean, I'm just trusting my math and that I'm getting the right thing. I have no concept of what I'm getting as a number at all for how long the snowboarder's in the air. So with that in mind, let's use the plus version of it. The minus version would give me a fraction. So or a negative, I should say. So 3 plus square root of 28.6. I'm going to divide that by 4. And I'm getting 2.09 about to the nearest tenth. So 2.1 around 2.1 seconds, which is fair and reasonable for a half pipe snowboarding launch and jump and catching the air and stuff like that. That seems to make sense. So like I said, when I had no concept of where I was with my numbers, that number makes sense. If it was 20 something seconds, I know something would have went wrong. I think everything went pretty right there. You can see that's definitely slowing down with the problems, though. Number 65. You have 80 feet of fencing to make a rectangular horse pasture that covers 750 square feet. A barn will be used as one side of the pasture as shown. Excuse me. Write equations for the amount of fencing to be used in the area enclosed by the fencing. 80 feet of fencing to make a rectangular horse pasture. So we have... When we take 2 W's plus a length, we're having 80 such feet. So we need to, when we do our length times width, listen, it's kind of a system of equations. When we have length times width, that equals 750. To make a rectangle that covers 750 square feet. We have 750. We have to write this in terms of like one of the variables. So I can take this one and solve for L. And write it as 80 minus 2w. If I substitute 80 minus 2w for L in this equation, like that, I've now created a quadratic with just w. What do they want? Write equations for the amount of fencing to be used in the area enclosed by the fencing. So this was part A. Part A was there. Now I'm working probably part B. Use substitution. Yeah, it's a system. Use substitution to solve the system of equations from part A. What are the possible dimensions of the pasture? So that's what I'm doing here. I got L by itself so I could substitute for L. Now I have an equation with only W's in it. This is the length, just written in terms of width. If I distribute W, now I'm going to have 80W minus 2W squared equals 750. I can divide everything by 2. In fact, by negative 2. I want to get this W squared positive right now. Let's write that. So that's a W squared, and then minus 40W equals negative 375. Divided everything by negative 2, put the W squared first. Hey, let's complete the square. W squared minus 40W plus blank equals negative 375 plus blank. Negative 40 divided by 2 is negative 20. Squared is 400, and 400 goes here. Looks like this was factorable because I'm going to have a perfect square value on this other side. W minus 20 quantity squared equals 25. I ain't mad. Solving by completing the square is fine. Taking the square root of both sides, we get W minus 20 equals plus or minus 5. Add the 20 over, you get W equals 20 plus or minus 5. 2 possible answers to be looking for. And listen, both might apply. They said, what are the possible dimensions of the pasture? oh, well, they said, well, R. Actually, I don't know if that works and how I was saying that, but there might be more than one answer here. We have possibly, maybe, W is 25 or W is 15. Now, these are in feet. It's very possible that both of these work. I'm very curious to see what would happen. If the W is 25, what is the length going to be? Let's go back. Length is 80 minus 2W. So length is 80 minus 2W. That would be 30. 80 minus that is 30 feet. And then on this one, length would be 80 minus 2W, which is 50 feet. Let's see if both of those work. 25 times 30. 25 times 30 is 750. I should have known that. 25 times 3. And 15 times 50 is 750. So both of these work as sets. So either, what are the possible dimensions? Either 30 by 25, 30 feet by 25 feet, or 50 feet by 15 feet. One or the other. This is one of those cases. This is very rare. This is one of those cases where there's more than one set that actually applies. There's nothing that's negative. There's nothing that overstays its welcome as far as stretching it. These fall within the realm of what we can do. So I didn't expect it, and there it is. All right, number 66. The graph represents the quadratic function y equals x squared minus 4x plus 6. Use the graph to estimate the values for which y equals 3. So now y equals 3 is right there. I'm guessing the x values are going to be 1 and 3. Oh, it said use the graph. So, okay, so yes, I'm going to just be talking about that. So y equals x squared minus 4x plus 6. Now for part A, my estimation is x equals 1 and x equals 3. Part B, explain how you can use the method of completing the square to check your estimates in part A. Do they want me to actually check it, or do they just want me to explain it? Set y equal to 3 and solve. I am going to go ahead and solve that. So we're going to get x squared minus 4x plus 6 equals 3. I'm solved by completing the square. It's the same method we've been doing. Subtract 6 over here and complete the square. This value will be 4. This factors to x minus 2 quantity squared. Negative 3 plus 4 is 1. Take the square root of both sides. You get x minus 2 is plus or minus 1, being the square root of 1. Add 2 over, you get x equals 2 plus or minus 1. So those answers, 2 plus 1 is 3. 2 minus 1 is 1. 3 and 1. Okay. They're connecting that, I guess, to 4.2. And whatever else. Number 67. Consider the quadratic equation x squared plus 12x plus 2 equals 12. I have considered it. I will even write it down. Solve by graphing. Well, I didn't expect this to actually pop up, but I do have graph paper stuff here for every assignment thing that I have. I don't know if I'm going to attach graph paper down in the PDF below just for a single problem, unless there are more problems pop up with this. So, if I solve by graphing, why don't we get this into vertex form over here? So, okay, we have different methods that we can use, right? Which one do you prefer? Let's use method number 2. Let's call this f of x. Let's call this g of x here. And in doing g of x, I'll make it a different color. G of x equals 12 is going to look like this line going across right there. F of x equals this thing. Let's see. F of x equals x squared plus 12x plus 2. I know there's a y-intercept at 0, 2, but let's get a little bit more. Let's get into vertex form by completing the square. X squared plus 12x plus blank plus 2 minus blank. This is 36. Oh, that's too big. Okay, maybe we can't use, maybe I can't use this one for, maybe I can't use method number 2. Maybe I can use method number 1 and fit on my graph, because my axes are quite large. So let's go ahead and do that again. My apologies. Maybe you shouldn't use this graph paper. Let's try method number 1 by setting this equal to 0, and let's see if it fits. If it doesn't fit in the conventional way, we might have to do something else. 12x minus 10. Ooh, I can't imagine this will fit. If the other one didn't fit, neither will this. Let me go back. I will use this. I'll just have to change my scale. So I don't know how I got to scale these graphs just yet. Let's keep method number 2. And let's get rid of these and see my scale for y. See, the problem with y here is that my vertex is at negative 34 for y. So f of, oh, well, that can kind of work out if I double everything. F of x is x plus 6 quantity squared and then minus 34, okay? So the vertex is at negative 6, negative 34. Now, if I scale everything by 2, that includes my x's, this will work out because this goes down to 17, negative 17 right here. So I can do negative 10, negative, let's put this on this side, negative 10, negative 20, negative 30. This is 10 and 20, negative 10, negative 20. You can see why I don't miss graphing. 10, 20, and 30. Okay, negative 6, negative 34 would be all the way down here. Let's go over 2, up 4. Over, remember, every 2 is a 2. Or every 1 is a 2. Over 4, up 16. So 4, 8, 12. I'm really bad at this when I have to change scales. Up 16. Over 6, up 36. So that'll be here. And over 8, up 64. So that'll be up here. Okay. Yeah. And here's my, it's going to be a bad curve, sorry. Huh. It's going to be a terrible curve. I can see part C asks which method I prefer. I think you're going to know that answer pretty fast. And here's y equals 12, by the way. Solve the equation by graphing. I have no idea where those two things cross. I mean, listen, I can use it. Listen, I'm going to have to use a graphing calculator. Because I have no idea. It's somewhere between negative 12 and negative 14. And between 0 and 2. I don't know where. I'm gonna have to use the graphing calculator. That's probably what they wanted us to do in the first place. But we do y equals, let's see, x squared plus 12x plus 2. And then y equals 12. So the window, let's see, let's do my same window. I did negative 20 to 20, and I did negative 34 to 34. Let's just make sure that I got the same graph that I wanted from those two things. So I'm going to have two equations. I'm going to have this parabola and that line. And I want to know where they intersect. It's kind of like what mine looks like there. So let's find the intersection. Let's go left of, oh, what did I just do? Intersection. First curve. Oh, I see what they're saying. First curve. Second curve. 0.78. I'll say about 0.78. Let me write these. Let's find the intersection on the other one. First curve, second curve. Now let's get closer over here. Where I say somewhere between negative 12 and negative 14. Negative 12 and negative 14. Negative 12.78. So negative 12.78. Okay, that's my solving by graphing apparently. Okay. So that was solving by graphing, using the graphing calculator with that. All right, now that was part A. Part B. Let's solve by completing the square. You bet. X squared plus 12x plus 2 equals 12. Let's subtract 2 from both sides. You get x squared plus 12x equals 10. I'm going to complete the square by adding something over here and here. And 12 divided by 2 is 6. Squared is 36. 36 over here as well. This factors into x plus 6. Quantity squared equals 46. and you get x plus 6 equals plus or minus the square root of 46. Subtract 6 over, you get x equals negative 6 plus or minus the square root of 46. Now that's exact set of answers. What do you think that negative 6 plus the square root of 46 is? Hold on, let's clear that. Hey guys, what do you think negative 6 plus the square root of 46 is? And what do you think negative 6 minus the square root of 46 is? Well, let me first get them set up, and then I'll show you. I won't even tell you. I'll just show you. So, what are they? 0.78 and negative 12.78. That's what we got before. So, same answers. Now, I'm not saying it as like, look how correct I am on both these answers. I'm saying, that was a lot easier. For one, I calculated those myself. Like, I knew what those were. I can't use my graph and tell what that... This graph is terrible, too. I made a terrible graph. Part C. Compare the two methods. Which do you prefer? Explain. Oh, man. The only reason I prefer the solving by graphing thing for any particular problem is understanding what your solution sets mean. And for word problems, sometimes. I much prefer the completing the square method. Method. Not only did I find it faster and more efficient, but my graph had to change its scales, and I had to approximate my answer. Now, when I say approximate my answer, I mean this two ways. I mean, I made a rough random guess somewhere between 0 and 2 and somewhere between negative 12 and 14. That's a terrible approximation, but I even approximated on the calculator. When I use the 0.78, stuff like that, they're just decimals. I have an exact answer right here. When solving by completing the square, I quickly obtained exact answers as well as their approximations. And I would know what they mean on a graph visually. So I don't mind the graph supplementing what it is they got in the other answer, but completing the square. I don't know if this is their way of saying, hey guys, use completing the square. I mean, anybody would probably do it over graphing, but there's that. All right, let's move forward. Number 68. Sketch, oh man, maybe I have to attach the graph paper online. Sketch the equation, sketch the graph of the equation, x squared minus 2xy plus y squared minus x minus y equals 0. Identify the graph. Oh, wow. They're going on hard on you right here. X squared minus 2xy plus y squared minus x minus y equals 0. I mean, I'm wondering if I should put the... Because I see a perfect square trinomial right here. I wonder what benefit I would actually have in making... Are they asking us to do it by hand, or they say use a graphing calculator? This would factor into x minus y quantity squared. I'm letting you guys know that right now. I don't know if that's helpful to do that, but I know that that's what you get from it. If I don't see benefit in that. What I'm also seeing, of course, is you have x squared minus x. What do I do? I see x squared minus x, and I could complete the square there, and y squared minus y, and I could complete the square there. But then I also have this 2xy term. There's not much benefit there either. I would have to think on this problem for sure. Considering that has a perfect square trinomial, I feel like there's something there I'd want to do. But there's a y involved. So, that 2xy. Sketch the graph, identify the graph. I think they want you to use a graphing calculator. Now, I can't pop up that browser for you right now because my graphing calculator that I've been using wouldn't work, but I'm going to use Desmos and see what kind of pops up. I wonder if it's a circle. It seems like some sort of circle business, but not exactly. Maybe some sort of conic. Plus y squared minus x minus y equals 0. Whoa. Yeah, I don't know what I would have done with this. I'm just going to kind of screen cap this and show you guys what this is. It's kind of fun. I don't know what I would have done with this here. So here's what it looks like. Hold on. I'm going to work this thing out for you. That problem's actually, this problem is actually kind of fun. So it's like this. It's like a crooked parabola. Yeah, I don't know what I would have done to make that work in a completing the square method. All I can tell you is that there's this perfect square trinomial that exists right there. I don't know if you were aware of that when I wrote it, but yeah, totally. Identify the graph. I don't know, diagonal parabola? Sure. I don't really know what to do with that problem. Looks good. Number 69. The product of two consecutive even integers that are positive is 48. Write and solve an equation to find the integers. All right, so for this set here, let's say x is one of your integers. Excuse me. The other integer has to be two larger. They're two consecutive even integers. I think the fact that they're even doesn't matter versus being odd. It's just that this answer will have even ones, but the fact that they tell us even just means you have to skip a value. If x is one of your numbers, your other number is 2 larger. If one of my numbers is 4, the other number is 6, right? Two consecutive evens. So when you take the product, they multiply to equal 48. That's our setup. Excuse me. Now we just solve for x and come up with those numbers. I'm going to go silent for a bit. I'm trying to hold my breath. Oh, this isn't working. All right, well, we'll try and get through it. X plus 1 is plus or minus 7. Subtract 1 from both sides, and we get negative 1 plus minus 7. We get 6. Negative 8. Now, they said positive integers. Negative 8's not going to apply. We can't use it. So just 6. So if x is 6, the numbers are 6 and 8. Because the other number is x plus 2. 6 times 8 is 48. I'm sure you could have done guess and check until you got that answer, but of course, and we could have solved by factoring, but of course, this is completing the square section. I'm going to pause. Okay, let's try again. Number 70. The product of two consecutive odd integers that are negative is 195. So same as the last problem where you have some number times some number that's 2 greater. Now, when you multiply, you get 195. And once again, the fact that they're odd lets you know that there's a difference of 2 between them. And the result will be odd. But we're going to choose the negative result from this because it's a quadratic that will probably be 1 positive, 1 negative. So x squared plus 2x is 195. Once again, completing the square. And I know this will factor down to x plus 1 squared. But you have to remember that you have to add 1 to both sides of this. Plus 2x plus 1 equals 195 plus 1. So x plus 1 quantity squared equals 196, which is also, of course, a perfect square. That's only what's going to make your evens and odds. This is 14, so plus or minus 14. So x is negative 1 plus or minus 14. So negative 1 minus 14 is the one that I want to go with here. It's that negative 15. This 13 ain't no good for what we want here. So negative 15. Now, negative 15 plus 2 gets my other number. So the numbers, did I say? The numbers are negative 15 and negative 13. Negative 15 times negative 13 is indeed, I guess, positive 195. 4 problems to go. You purchase stock for $16 per share. You sell the stock 30 days later for $23.50 per share. The price Y in dollars of a share during the 30-day period can be modeled by this equation. So let's write that out. Y equals negative 0.025 x squared plus x plus 16, where x is the number of days after the stock is purchased. So this is your value, number of days after stock. Your friend says you could have sold the stock. You could have sold the stock earlier for $23.50 per share. Is your friend correct? Explain. We want to see if $23.50 exists on this graph somewhere, and where we could have gotten that. Wait a minute. Oh, it said it could have sold the stock earlier for that. We're going to see if there's an earlier x value than 30, which gives us this. And I wonder if fractional days count. I assume they probably could a little bit because you can day trade. So let's see. We don't trade during after hours now, do we? Let's subtract the 16 over. Sorry, I'm going to add this over. 0.025x squared. Let's make that positive. Subtract the x over. And now let's subtract 2350 over, and we'll get negative 750. I will be getting this thing up higher. What is it? What do I multiply? 400? Let's see. 0.025 times 400? Oh, no, times 40. Multiply by 40. So if I multiply everything by 40, I'm going to get 1 on that side. So times 40. That'll give me a 1x squared. So x squared minus 40x equals, what's 750 times 40? That should be 300? Negative 300? Negative 750 times 40. Negative 300. So negative 300. Pretty decent numbers all told from what we started with. Completing the square, x squared minus 40x. We've seen this a couple times, plus 400. Equals, oh, very good numbers. Negative 300 plus 400. This was even factorable, which means that it's probably going to be a positive number here, or an integer. So x minus 20 quantity squared equals 100. Take the square root of both sides. You get x minus 20 equals plus or minus 10. So x equals 20 plus or minus 10. I guess I should have expected that because 30 would be one of the answers. So x equals 30. We already knew that one, so let's ignore it. And x equals 10, which would be the other one. As long as we're within the 30-day window of a positive number, then 10 days later, your friend is correct. Yes, friend is correct. I don't really have much to explain other than 10 fits between 0 and 30. And it's another value that does work out. Now, last time I think the cousin was correct, right? It was either friend. I can't remember. It was either friend or cousin. But yes, friend is correct. Now, I multiplied everything by 40 to make it nice and clean. And that's what works it out. Good question. Number 72. You are solving the equation x squared plus 9x equals 18. Sure I am. Let's go ahead and write that out. X squared plus 9x equals 18. What are the advantages of solving the equation by completing the square instead of using other methods you've learned? Well, this is factorable. Wait, is this factorable? No, I don't know. You know what? I don't know if this is factorable. So hold on, let me solve this. X squared plus 9x plus blank equals 18 plus blank. I don't think this is factorable. I was thinking of I don't think this is factorable. Okay, anyway, so one reason why this is beneficial is you can solve it. I can't solve it by factoring if it's not factorable. 9 divided by 2 is 9 halves. Squared is 81 over 4. So we got 81 over 4 going on both of these. This will factor down to x plus 9 halves squared. And 18 is also 72 over 4. And 72 over 4 plus 81 over 4 is 153 over 4. Definitely not factorable. That's not a perfect square. It can, however, it does have a perfect square factor. You can factor, is that the right number? 153? Yeah, you can factor a 9 out of there. Get 9 times, what is that? 17? 9 and 17. So that becomes, when I'm square rooting this, okay, this is plus or minus an over 2. That's 3 root 17. I didn't expect that. I almost thought that was a prime number. So that works out as 3 root 7. I guess that makes sense. These are both multiples of 9. So 3 root 17 divided by 2 and subtract the 9 halves over. I get negative 9 plus or minus 3 root 17 over 2. It's the first time we actually got to simplify a radical in this thing. It kind of upsets me that it's the first time. But there's an exact set of answers. And I think that kind of benefits from what we're talking about. Even if we use quadratic formula, which you haven't gotten to yet, completing the square is still somewhat beneficial to quadratic formula for that. They don't ask for disadvantages for here. They say, what are the advantages? They're still trying to convince you. Compared to solving by factoring, this has an advantage because I can actually solve it. This is unfactorable. Therefore, I cannot solve by factoring. We've talked about solving by graphing as well, where I don't get approximate things compared to solving by graphing. I can determine exact solutions as opposed to approximate them. Compared to quadratic formula, I would probably like quadratic formula more, just because that was a 9 instead of, I had to deal with fractions. But I'd still have to be simplifying radicals of quadratic formula, and I'd probably get a much bigger number with that in general. But we haven't used it yet, so I can't talk about it with you guys. All right, 2 more questions. Number 73. You are knitting a rectangular scarf. The pattern results in a scarf that is 60 inches long and 4 inches wide. However, you have enough yarn to knit 396 square inches. You decide to increase the dimensions of the scarf. 60 inches. So 60 times 4 is 240. So, okay, there's more. You decide to increase the dimension of the scarf, so you will use all your yarn. The increase in the length is 3 times the increase in the width. What are the dimensions of your scarf? So here's the rectangle. Here's the initial rectangle, if you will, of a 60 by 4. 60 by 4. But we are going to extend this thing so that it now, kind of like takes on this. But if this just goes x more, this goes 3x more here. However wide, the length 3 times the increase in the width. So however much I increase here, I'm increasing 3 times the amount there. So I have a 60 plus 3x. I'm right, 3x plus 60. I have a 3x plus 60 times an x plus 4 going on. And when I multiply those, I'm getting 396. What are the dimensions of your scarf? So I believe that's what they're talking about when it comes to the increase. So let's distribute that thing out. Actually, let's factor out the 3. Screw this. Factor the 3 out, and we get that. The reason I do that is because I want to get rid of that 3 as soon as possible. I can divide everything by 3 right now, and I get x plus 20 times x plus 4. Don't worry, I'm still going to distribute that. I just want to make sure I get this thing set up. That's 132. Like that. So now I get to distribute here in FOIL. X squared plus 24x plus 80. Like that. Much better for me, I think. So x squared plus 24x equals 52 when I subtract 80 from both sides. Let's go ahead and complete the square. Half of 24 is 12. Squared is 144. So let's add 144 to both sides. And this factors to x plus 12 squared. 52 plus 144 is 196. Perfect square value. Take the square root of both sides. We get x plus 12 equals plus or minus 14. That's the square root of 196. And then we subtract the 12 over. X is negative 12 plus or minus 14. We're going to do the negative 12 plus 14 to get 2. So 2 inches is added to both of these. Well, I'm sorry. 2 inches is added to one part. 3 times 2 inches is added to the other. X is 2 inches, 3x is 6 inches. So your length is 6 plus 60, which is 66 inches. And your width is 4 plus 2, which is 6 inches. And 66 times 6 is 396. I'm guessing. Yes, it is. Last question, number 74. How many solutions does x squared plus bx equals c have when c is less than negative b over 2 squared? Explain. Well, here's the thing about negative b over 2 squared. You have to remember that when I complete the square here, x squared plus, x squared plus bx plus this thing, this becomes b over 2 squared. So what if you have that, and on this side you have b over 2 squared that you have to add to both sides to complete the square? If c is less than negative b over 2 squared, then see if I add c plus b over 2 to both sides, let me kind of write this over here. If I add b over 2 squared to both sides, then you'll have c plus b over 2 squared is less than 0. And if that's negative, that's a problem, because now you're talking about something where you're factoring. If x plus b over 2 quantity squared, I'm going back down to this guy right here, this thing will be now equaling a negative number. This will be less than, well, equal to something that's less than 0. Do I just say less than 0 by saying that? I'll just say equals negative on this side. Equals a number that's less than 0. And that's a problem, because this is taking the square root of both sides here. How many solutions will it have? It'll have no real solutions. Whoops. No real solutions. Now, it's interesting, you know, this entire time I was expecting if we were going to run into some problems where we would complete the square and have no real solutions and just talk about that. Never did show up. So compared to solving using square roots, we never really did run into that scenario. Though it still exists, it's still a portion of what we do. And this is our first time of actually bringing this up. If c is less than the negative b over 2 squared kind of thing, you have a negative on this side. Taking the square root of both sides means you have no real solutions out, because you can't take the square root of a negative. That's my explanation on that one. And just through the work that I'm showing you, that's what we'd actually get. All right, guys, that'll do it for this one. This is Mr. Robinson. Thank you so much for watching. This video ended up being incredibly long. It's time for me to pack it in. Hopefully my steak digested after this time. Take care, guys. I will see you in the next one.